working on Fridays. So you can make the command decisions, and then I can do kind of sweeping maneuver at the end, for anybody that can't make it on the 20th, if that's what you all decide. They could do it anytime that week. It's up to them. So
Dr. Bird, could we have the presentations due on the 20th and the reports due on the 4th?
Yeah, I'm okay with that.
And no test?
Oh man, what? Did you go to law school too, Mia? All right. Yeah, that works. So by vote of thumbs up, how many people want to have the presentation and everything due on the 24th with a test on the 20th? Let me rephrase that. How many people want to do the presentations on the 20th with no test? Everybody. How often do you get unanimous decision? All right, so be it. No test. You'll find the homework excruciating. No, you won't. So I will say.
And then the written report, as per Mia's suggestion, will be due on the 4th.
Yeah, and Alex reminded me that. Well, I thought I hadn't posted the that I had promised, which is kind of a template for the presentation and for the Word document. I will also mention that I provided a ton of example projects. I don't know where they are, but they're someplace in Canvas, which could kind of serve as examples too for your write-up. So if you can't find them, shoot me a note. And I will say, Beth, it is easier for me to respond to emails via Outlook than it is the going through Canvas, only because to respond back through Canvas, this is me being petty and selfish. I got to jump back on Canvas and do the notes again. Either one is fine. It's just a little bit easier. So if I'm out doing something and I get something on my phone and it's an email, I can respond. So what Canvas does, if you send a note in Canvas, it sends me an email that you sent a note in Canvas, and I can't get to it. So you have to wait for me to get back. So if it's really easy, I can respond to you almost immediately if it's an email. All right. So that's done. So no test. Presentations on the 20th. 5-ish minutes. Actually, it can probably go a smidge longer since we have a smaller class. I'm sure we're going to have some stragglers, and so I'm going to need to have sweep up the stragglers and have something later. It'll be via Zoom, and you present, and you'll get a chance to share your screen and present the slides. You only have time for 3-ish, 2 to 4 slides, right? And so it's other than the title slide and maybe a couple bullets on describing it, it's mostly either your jump analysis or experimental setup, jump analysis, and some graphs, probably, right? All right, so that's that. So what we were talking about last week, we were talking about we had gotten into factorial design, which is one of my favorite areas. I really like factorial design. And do you recall what the primary benefit of factorial design is? So if you think about everything we were doing before, also great approaches, but the issue was that you couldn't measure interaction. and recall we were talking about main effects. And so main effects are the impact that any of the factors that you have. So in this example that's up on the screen, the two factors are room temperature and test difficulty. Okay. And what they're measuring is score, what the test score is. And so the main effects would be the effect from the difficulty of the test or the room temperature. And the issue is we don't live in a world of main effects. What does that mean? That means that many of the factors will have some amount of interaction. And so if we sit back and if I ask you to write down a list of various factors that you might make up an experiment, or even in the projects that you're working on, you could pretty quickly come up with a whole bunch of them, like temperature and humidity. Yeah, I've used that one before, right? So as temperature rises, humidity goes up, and it might not be linear. I mean, other sorts of things are height and weight. And so you might be looking at drug effects and measuring height and weight, and those two things interact. The taller you are, the more you weigh. So there's a bunch of things like that. And so just to review these main effects, so if you look at the graph on the right of your screen, think about what you see there. So when we go from 50 to 90 degrees, so they turn up the thermostat in the room, we go from 50 to 90 degrees. Do we see an effect from temperature based on this data on the test results? Just think about it. And so since you don't see a change in the slope of the line from 50 to 90 degrees, there's no effect. So temperature, students do the same on the test between 15 and 90 degrees. Now, between the difficulty of the test, you see a difference, don't you? Not surprisingly, the easy test, the students do better than on the hard test. So when you look over at the data table, you see that between 50 and 90 degrees, there's no change. On average, they all get a test score of 70. But between the hard and easy, they do better by 20 points between the hard and the easy. And recall that we calculate main effects by taking all the data. So we could have 10 different temperatures. We can go up by increments of 10 degrees if we wanted to. To measure the main effect, we take the average of these. So it would be, in this case, 60 plus 60, well, that equals 60. 80 plus 80, forgot to say divided by 2 is 80. And that 60 plus 80 is 1. So that's how we measure main effects. Now, if we, let's change the data a little bit. So if we look at, we calculate main effects the same way, and you see what they are. But here, what do you see a change as a result of the temperature? Yeah, you do. So if you go from 50 to 90, you see that the test score has gone from about 60 to about 70. Well, yeah, that makes sense here. So as the temperature goes up, the test performance goes up. And that's true for both the easy and the difficult. And so the main effects are those things kind of that you initially look at to say, hey, I wonder if there's something going on with this. I wonder if, as I change the levels of my factors, so in this case, I change the temperature from 50 to 90 degrees, is it having an effect on my output? And that's the sorts of things that we looked at in all the previous things. And so what we're interested in, I'm going to skip ahead here. One thing to say is, so we're not limited to just 2 factors, right? We can have any number of factors, and that's also a strength of factorial is You have 15 or 20 different factors if you wanted to, with multiple levels in between. It just adds to the complexity of what you're doing. What we're really interested in is in the interaction. So it's the effect that factor A, say test difficulty, might have on the outcome of factor B, or say factor B, temperature has on factor A, which is the test difficulty. Is there any interaction between the two? And so one way to put that is the difference in the differences. It's a difference. It's that there's a changing temperature creates a difference in the output or result from the other factor, and it has an effect on the dependent variable or the result that you're looking at. So I give you a bunch of definitions here they can look at, but the bottom line is at the end of the day, you'll see that the slopes aren't parallel. And that's the thing that you're looking for interaction, is even in the ones where, let me go up here. This one. Even where you see that two different main effects, there's still no interaction because those lines are parallel. It's when they depart from parallel that you have some interaction.
When you say interaction, you mean interaction between those two factors, right?
Yes, ma'am. Good point. Yes. Yeah, so we're not looking. So our expectation might be that our factors result in a change in the dependent variable, right? That's kind of what we're measuring. And so if we're looking at height and weight as independent variables and drug response as our dependent variable, we sort of expect that, as we change height and weight, that we get a change in drug response. So it's not that. So Mia, you're right. It's as we change height, does that have an influence on that other factor, weight? So let's look at that a little bit. So I think we looked at this one last week. So this is made up data. I forget where I got it from, but we're looking at consuming alcohol and not consuming alcohol, and then taking caffeine. And this is just looking at the main effect. And it's a little bit hard to tell here because I don't have a graph. So let's see if we can make a graph. Let me see if I can make a graph for you. So I think I added this to your, if you want to follow along, to the Canvas site. So if I copy this over right, we have no alcohol response, and no caffeine, medium caffeine, and high caffeine. And so let's go over to, this is always dangerous to kind of do it on the fly. So this is our friend graph builder, right? And so our response goes on the up and down axis. And where should we put caffeine? Let's put it down below. And then let's drag this over to overlay. There you go. How do you like that? It actually worked. So did everybody see what I did there? So now we got to graph this. And so this looks very similar to the earlier graph. So do you see any interaction in this? Would be the question. So give me a thumbs up if you see interaction, or a thumbs down if you don't see any interaction. is an easy vote. You're not graded on this vote. So I'll give you a hint. Yeah, Alex, you're right. So if the lines are parallel, there's no interaction. And while we don't have any reference lines on here, we haven't done any t-test or anything like that. They kind of look parallel to me. Maybe they look parallel to you. Now you might say, well, yeah, but they're sloped. Yes, they are. But that just means that there's two main effects going on between caffeine and alcohol. But they're parallel, which means that there's no interaction. Let's see if this really does it for me. If instead, say, what is blue? Alcohol. So if instead this blue line went like this, instead of, so it's not this one, it's not that one, real one. So it's this one. We say that, well, there is an interaction between the two because they're not parallel. So that means, so if we go back and look at this, how we'd interpret this graph is that this has got high, medium, and no, so low caffeine. So it's kind of backwards of interpreting it, but the more caffeine you take, the lower your response time, right? And so we have high caffeine here. This is our area of high caffeine. And whether it's taking alcohol or not, we're reducing our overall response time. Our response time is getting faster. And we see also that between alcohol and no alcohol, alcohol and no alcohol, the spotted one is no alcohol, that the more, if we drink alcohol, our response time is slower, right? But it's consistent. There's no change between this and this. There's no interaction at all. The reason is because there is no change in the slope of the lines between the two. There's consistent slope along both lines, okay? So the easy thing to remember is if they're parallel, there's no interaction. And it doesn't matter how they're not parallel. So whether they diverge, converge, or cross, come to a point at the end, doesn't matter. If the slopes are different, then there's an interaction. Oh, okay. Yeah. So let's get out of that. Don't need that anymore. Okay, so that's what the slope would be. No interaction. And that makes sense because this is a cheat for you would have been, you saw this, main effect only. And so we're not looking at interactions. So let's look at the interactions. And it's a little bit hard to tell from just looking at the table. So let's look at the graph. So this is the graph. And there's a hint on this chart. So do you think that there's an interaction between alcohol, no alcohol, and caffeine? Yep. How do you know? The lines aren't parallel. And so as caffeine's going up, our response time, so as let me get back to this. Okay. So this direction, we're increasing our caffeine consumption. And so as caffeine goes up, our response times are getting faster, right? Which means that this is a response time. So we're getting quicker. But we're getting quicker at a different rate for each one. So with no alcohol, it's a pretty shallow slope. And so caffeine has some effect, but not as much as alcohol. So if we take alcohol and caffeine together, that what this is saying is that there's an interaction between the two. So alcohol and caffeine are interacting to lead to a faster response time. And so to carry it to an extreme, so if I added another data point at the end. And so try to guess, take a second and try to guess what this is saying. So it's the same slope roughly as before. What this is saying is if you take this much alcohol or this much caffeine, then at some point your response, and you've taken alcohol, at some time your response time would be faster than if you had not taken any alcohol at all. So what this would say is that if you drink and take a lot of caffeine, you're going to be a much better driver than by not drinking alcohol, which isn't true, I wouldn't think. So these are just some other definitions of interaction. Basically, it's when you put two factors in a bin together and you get some sort of increased positive or negative result, that's what interaction would be. And so this is looking at that synergistic effect, which is just kind of what we were showing before with those lines. So you can also see this sort of thing too, right? And so again, you look at this, and this would be a divergent interaction, not parallel, saying that there is an interaction between the two. So here's quiz time. So looking at the top graph here, is there an interaction? Nope. Is there? How can you know that there's? So let's see if I can help with this. Let me do this one. So this is factor B, and I don't like the way this table is set up. So let's just say this is factor B. So let's just say this is low, and this is high. And this is no. And this is yes. Is that okay? That's a Y. And so that this means that we didn't use chemical A, we did use chemical A. And this means that it was low temperature, and this means that was high. We're just making this up, and this was high temperature. And so let's look at this graph over here and see where there might be a main effect. And so we see that when we moved from low to high, was there an effect? So let's look at this and see if our response changed when we moved from low or high. Well, on factor A, it seems like it's a pretty straight line, right? So there's no effect there. And we moved from low to high on factor A, on top value factor A, there's no effect. So there is no effect. So this is factor B. There's no effect from factor B. You see that? Because when we go from low level to high level, there's no change. Now, let me go back. What about with factor A? So this these lines are factor A. So the no level, the bottom one's no, had about 10. And where we used it, it's about 20. So we went from 10 to 20 by switching from no chemical A to chemical A. Was there an effect? Yes, right? Because we went up 10 points. Y'all get that? Yep. Okay. So with this, there's main effect from both. Well, that kind of makes sense. So if you compare it to this one, we moved from, what was it, low to high? We got this increase in slope. So it makes sense to say, not only do we realize, based on our decision above, that there was an effect of factor A, but the fact that we went from 10 to 30-ish when we put factor B in means that we had an effect from factor B. So on this bottom one, we have no effect. So how can we say that there's no effect? Well, if you look over here, versus here, and so there's an effect, here's an effect, because you can see the changes. Here it's 20-fold or 20 unit increase. Here's a 10 unit increase. Here there's no change, and here there's no change. So there's no main effect, but there is an interaction. Why is there an interaction?
Is it because they swap?
Say it again.
Is that because they swap like they do?
Yeah, exactly right.
Change.
Yeah, they're not parallel. And so anytime that it doesn't matter how it's not parallel, just that it's not parallel means you have some sort of interaction. And an interaction isn't good or bad. It's just that whatever those factors are, so that chemical and the temperature change, so let's just say that factor A is a chemical and factor B is a temperature change. That those two are having some sort of synergistic, either positive or negative, synergistic effect on each other. And it happens all the time, right? So, an effect an interaction can have is it can sometimes mask what the main effects might be, because the interaction is so strong. It overrides the statistical signal that you're trying to get out of it. So you just need to be aware of that when you're doing the analysis. This is talks to us about we can continue this with more factors. In fact, when we get into some of the examples, we'll see multiple factors. So here's a fun example, I think. So if I asked you, as statisticians now, design of experience experts, do you prefer chocolate or mustard on your food? What answer would you give? And you should give that answer that I always give, which is, well, it depends, right? So let's explore this some. So to keep our experiment simple, we have as food choices, ice cream and hot dogs, 2 American favorites, and chocolate sauce and mustard. All right, pretty easy so far. And this is a two-way ANOVA. Why is it a two-way ANOVA? Well, we have 2 factors, right? And when we have 2 factors, that means it's a two-way ANOVA. And we have 1 dependent variable, so enjoyment. So we're taking that qualitative factor and kind of assigning a numerical value to it. And so if we were to do the just the effects test, the factor effects, the main effects, here's what we'd see. So this actually came from Minitab. So here's hot dog here. The ice cream, and there is a bit of a difference between the two, right? Not a whole lot, but people tend to prefer hot dogs a little bit or ice cream. All right, not questioning their choice. And people prefer significantly chocolate sauce over mustard. And so what conclusion would we make from this? If we were setting up a new fast food franchise and we were featuring hot dogs, what condiment, and we're going to keep our costs low. So we're going to reduce the number of condiments that we had. Based on this information, what condiment will we choose?
Hot dog and chocolate.
Hot dog and chocolate. I mean, what more could you want, right?
But isn't this where the parachute analysis had come in?
Yeah. Yeah, you just proved you read that paper. Yeah, wasn't that an interesting paper? Actually, that paper was in the top 100 papers of 2019. So there is, they list the academic papers from all disciplines based on readership and kind of like the quality of the paper and that sort of thing. And that paper was ranked like number 48 or something like that. So yeah, you're right. So we would only pick hot dogs and chocolate sauce. Delicious. So that's the danger of not looking at interactions, right? So let's look at the interaction. So so if you run this in JUMP, and I actually think I included this in, if you wanted to run this in JUMP, let's do it. See if we got it open. So here's the data table. We're not going to go through all of it. So I don't think we've used JUMP in this way yet, have we? It's very similar to everything else. So this would be our dependent variable, right? That's the thing that we're measuring. And then we add food and condiment in our model effects. The thing that we do differently here, though, is remember what we're looking at? We're looking at interactions. So some way, somehow, we have to get the interactions. And the way you do that is you highlight the two interactions that you want, and you do cross. Quite literally, that's telling JUMP is, so take food, look at food, take condiment, look at condiment, and then when you do the analysis, when you do that all sigma, all that stuff, is saying add this factor in. So when you look at the two together, give me the answer for that too. If you noted, I notice I changed this to effect screening because for me it's easier. Click on run. And here's what you see. What I should show you. So what is this? What is this saying? So it's saying that food's not so much of an issue. Well, it's p-value above 0.05, so it's not an issue. It's saying that condiment is an issue, so you need to consider condiment. And it's saying that there's a significant p-value for interaction. Let me do something first. So I'm going to go back to this. Recall. And I haven't done this yet, so let's just see if we include those two, what they do. So this is interesting, right? So what this is saying is that neither neither food or condiment are from a statistical point of view, p-value, important. So you could have either one. Actually, you look at the data that this guy did when he did this data is you ran it in Minitab, and that's where those main effects were. And I think you have to do that in fit y by x. So let's come back and look at this. I'll show you one more thing. I'm going to rebuild this. So did you see what I just did? So these are full factorial models. And what that means is you're doing the interaction for each one. So what I did was highlighted both food and condiment, so they're my independent variables, went to macro and hit full factorial. And then run it. And here's our results. You remember these prediction profilers? And so what this allows you to do is if we switch from hot dog, so what this is saying is when you pick ice cream, chocolate sauce is much gooder than mustard is. If we select this, this is saying if we have mustard and we want that as our condiment, then hot dogs is much gooder than ice cream is. Okay? And you can do a variety of things with this. Get the interaction profiler. It's one thing where it's yeah, I don't want to do that. But we'll come back and look at that later. There's a way to get it to optimize for you. I think I need another variable in order to do that. Okay, so that long-winded example is saying that looking at interactions is a very important thing to do because you don't know what the effects might be of interactions, and they could be much more significant than any one of the main effects might be. And here's that result. And so just to read this chart, it says, if you pick hot dogs here, now I keep going back and forth to this. Does this on-screen highlighting help, or do you find it annoying because I'm switching screens all the time? Silence. Okay. All right. So if you look at where our hot dogs here, so let's look at. In fact, I kind of find these lines distracting a little bit because I try interpreting the slopes, and that's not how you do it. So if we look at hot dog, and then we look at where this goes up here, is saying that so this is mustard over here, and this is chocolate over here. So if we look at hot dog, our chocolate is low, but our mustard is high. And if you look at ice cream, our mustard is low, but our chocolate is high. And so there's that kind of reciprocal interaction between the two. That's what the cross is.
Dr. Bird,
Yes, ma'am.
can we kind of summarize what that data showed? I think I saw on one of the plots where looking at the main effects, looking at the selection between hot dog versus ice cream, there wasn't much of a difference. So if you were an entrepreneur and you were trying to select between what type of shop, there's a slight increase in improvement relative to hot dogs, as opposed to ice cream.
Right.
But then when you factor in condiments, there was an opportunity to increase that level of enjoyment based upon the combination of each of those foods with a particular condiment, and that would be your interaction. Is that?
Yes. Yes. And so what this plot shows you, the one that's up on the screen now, is it is the main effects. And so Mia, you're absolutely right. If we just looked at this, what we see is, without looking at any of the statistical analysis behind it, that there's only a minuscule difference between ice cream and hot dog, right? And so you might say that on this, that, well, it really makes no difference, or hot dog seems to edge out, although we haven't looked at it if there's statistical significance in this. That hot dog might be a smidge, preferred a smidge more than ice cream is. However, people like chocolate sauce a lot more than mustard, according to this, right? So you're absolutely right. Now, if we go and they hire you guys at an obscene level for a consulting fee, you'd do this experiment. And what you'd say is, well, to be perfectly honest, there's no statistical, looking at this. So I should ask you to interpret this, not you, Mia, but you, or maybe you, Mia. There is no statistical difference between hot dogs and ice cream, right? HO is low, it's got to go. Our p-value is way above 0.05. So what this is saying is, when you look at that, you could use either hot dogs or ice cream. It doesn't matter statistically. What does matter, but the choice of condiments does matter. Well, this won't tell you, this p-value here doesn't tell you which is gooder or which is worser. It just tells you that there's a difference between the two. And what this tells you is that there is an interaction between the two. Here, the null hypothesis would be status quo, no difference. And this difference is that the interaction does make a difference or doesn't make a difference. In this case, we reject the null hypothesis that there is no difference in preference. So there is a difference in preference. And then we would go on and continue the analysis to say, well, what do they like more? And then we come up with, this, which we'd say, oh, so it does make a difference from an interaction point of view. So that with hot dogs, we know that they really like mustard. In ice cream, they really do like chocolate sauce. And maybe you'd have to decide that, well, so if I'm going to have then you start putting in economic variables, which we haven't done in this, to look at cost factors for optimization. Right? So that's the point you're getting to, which is absolutely the right point, because those statistics in and of themselves, if you went to your manager, you'd say, well, great, but so what do I need to do? You just told me that people like mustard on their hot dogs. I could have guessed that, but what's going to cost me more? And so that's when you get back to have you guys had optimization yet? Or is that coming up? That's coming up.
Mm-hmm.
Next semester, probably, right?
Yeah, it's next semester.
Who's teaching that? Don't know yet?
Don't know.
Don't know.
I'm just curious. So if we get to it, we'll do some optimization. Use JUMP to do some optimization. We'll add in like a cost factor and figure out that, well, a hot dog costs 15 cents, ice cream costs 18 cents. because of the total cost of it. And then chocolate sauce costs this, and mustard is really cheap. It costs a penny a gallon. And figure out, based on that, which is the optimal mix between the 4 items. So that's how you do that. Does that make sense? Yes, no? Um,
Yes,
Thank you.
thank you.
So we're going to run this example. I actually don't think it's page 197. It's in your book, though. It's the first example. Jeez. Uh, 161. So I actually think I gave you the data, right?
You did.
Yeah, I did. Hang on, no problem. All right, here we go. So here's the data. It's interesting with this. So I had a fat fingered this in. I think I did it this morning. And because this version of the textbook doesn't have electronic versions of the example data sets. And I got one of the numbers wrong. And it was completely throwing off the result, like a lot. And it was like 160 and one instead of 168. So I use that as an example, just how much, because that's not a huge percentage in terms of overall difference between the two. It was a significantly different result. So let's do this. Actually, no, let's have you do it. So everybody open up Jump if you don't have it open. Open up the data set. Don't cheat by hitting recall. I don't know if that will do it or not. And see if you can build the model, and then we'll do it together. Tell you what, let's take a 10-minute break. And you can do that as part of the break. And then in 5 minutes after 10, we'll get back and we'll see what we got. How's that sound? I hear applause in the background. All right, 10-minute break. Plow through this and we'll see you at 5 after. How's everybody doing? Got a minute or two left.
Watching you play on your screen, I think I went the wrong way.
No. I was just, actually, I was messing around. I didn't say anything about checking the data, so I figured I'd go ahead and do that, and we can talk about it really quick.
Okay. So when I looked at mine, you always have to change your factors.
Not always. In fact, I was just I'm glad you brought that up, because I was just gonna do that too.
Okay.
And it's so you're gonna hate this answer. It depends, right?
I
So-
noticed you like those depends, by the way. I like that. You keep.
I know. So you can't be held. Yeah, so when you're doing your capstone and you say, well, Dr. Berg told me, as well, it depends. Depends. And so we'll talk. I'm glad you brought that. We'll talk a little bit about that, because it even if it's a nuance, it changes some things and it can change how you interpret it. I got messed up big time on that project I was doing. When the data is the data, right? But it can affect the analysis. And so I have not looked at what it does to this, but we can look at that. Can you hear my dogs in the background?
Yeah, is that your siren too?
Yeah. Now, I don't know which dog that is. Okay, let's launch here. So what we were just talking about is just more for grins and giggles, I went through and did the adequacy check, at least part of it. And so, the data looks pretty good, right? So if we just do the real simple normal quantile plot, it all looks like it's falling right in line. You can overlay not that this really tells you much of anything, the normal curve here. If we go down and do I think I told you about a QQ plot, which is basically this line here. QQ is basically this line here. There's also, so there's quantile by quantile plot. You can do a percent by percent plot, which, all you're looking for, are consistent inconsistencies, right? So you don't want to see like a big departure going up, or data showing any kinds of uniform departure across this line. Does that make sense? So I hate this thing. So you wouldn't want to see, so this is good. You wouldn't want to see something like going like this, or significant, right? So you see a little bit of that here. It is not enough to worry about. You can see things that go like this with the data set. So the dots would be, oh wait, let me do that over. So it's kind of doing, if you were to kind of draw a line between the means of both those, it kind of look like that. But what this is showing you is the change in variance as you go along. And ideally you have consistent variance. So you, being smart folks, would say, well, what happens if you don't have consistent variance? Does that mean my data is no good? The data is what the data is. What it means is that you analyze it a different way, and there's different tools that you have for where the variance changes over time. Why the variance change over time? Well, it could be that like you have bad sensors or something. right? It could be that your sensors are perfectly good, but say you're working with extreme temperatures, and the more extreme the temperature gets, the wider diversity you get in readings. It's your temperature or your sensors are perfectly good. It's just that you get more departure from what the standard deviation would be, or from the center of the point. That's okay. It just means that you need to analyze it differently. So our data looks pretty good. And then I plotted it, right? So we did that example once. And so to the earlier question, so this is what the data looks like. And so you'll note over here on the left-hand part of the graph builder that I've got 2 nominal and 1 continuous. And we'll always have that, for what we're doing mostly, we'll always have that continuous, which is our dependent variable. Now the question was, I think in the data set, one or both of these were continuous variables, right? I think, can't remember. Let me look. Let's just, so I'll come back to that. They were both, at least on mine, nominal. So let's interpret this first. And so with material type 1, as the temperature went up, it whatever that time, battery life, right? Battery life dropped to 50 minutes and then stayed at 50 minutes so it went to 125. So we had 3 separate temperatures that we were testing as in this case as nominal variables. Material type 2 decreased some when we went to 70 and decreased a whole lot more when we went to 125. And material type 3 lasted 144 minutes, then went to 140. So it actually went up a little bit as the temperature increased, and then it went down when the temperature went way up. Now we could ask ourselves, just based on this, which battery would we pick? And based on this curve, you know, if we're working with, so let's say that this is for the military, and if we're working in like a temperate climate or a desert climate, you'd probably pick the green type of material, wouldn't you? Right? Because the battery life is better at 70 and above, is better for the green material than any of the other types of materials. But if you're dealing in the Arctic, you'd pick, you know, where it's always cold, say, you'd pick, just based on this graph, material type 2, right? So material type 3 for anything other than Arctic, and material type 2 for real cold temperatures. Now, let's see what happens if we change material to a continuous. What changed? Did you see that change? And so here's something to be careful of, is all that changed in this particular case is the axis changed. So see how you have more hash lines in there? So what continuous means is that it's numbers, and you can interpret anywhere along this line and say that as a continuous that this is a reading at exactly 45 degrees. You can't say that really technically if you go back to nominal, because what you're saying is I'm just taking a reading just at those temperatures. I don't know what's going in between those temperatures. I just know what's going on at those temperatures.
So is there a distinction of when you do that and when you don't?
That's a good question.
Looks like I could play with it if I wanted to and make it say what I wanted. Is that
Yeah, that's absolutely right.
okay?
So so in this particular case, it probably, and we'll look at what the analysis says in just a second, but it probably doesn't make a difference in this particular case. You know, if you're looking at 3 independent settings, then and the categorical represents adequately represents it, then I'd say it doesn't matter. But let's see if I can prove myself wrong. So we're going to run this 2 different ways, and so no, wait, yeah, I don't know. So here's how we set this up, right? Right? Is that what you guys did? When we run it? And without doing much more, this is if we look at the temperature, material type, and your interaction. And so this is the same kind of evaluation that we've done before, where we look at our p-values, and this says that in every case, both temperature, material type, and their interaction, all are significant, right? They're all below 0.05. And if we wanted to do something else, we'd say, well, all right, so including interaction this time, what is the best material type and temperature? So let's go here. So we say material type 2 and temperature 15. That's the best one. Material type 3 is better at 15. It's also better at 70. Not as good at with 50. So that's that. Now what I want to do I want to talk about this? So do you all recall that, oops, sorry. So we can get the independent interactions here. So this shows us that if you were interested in any specific thing, what are the important elements that we want to consider? And so this shows us which are important for the interactions and each individual, which ones are important. I'll leave it to you to interpret, but it's the same way to interpret as the other p-values. And so those that aren't colored are not statistically significant. Those that are colored are statistically significant. Now I want to get back to the point. What happens if I'm going to move this off screen for just a second. Let me get rid of that. We're going to go up here. And we're going to run our own experiment here. We're going to say, what happens if we change this to continuous? Is there a difference in the results? We should be able to hit recall. Yep. So let's try and see what happens. So over on the left is where we treated temperature as categorical. Over on the right, well, we can see that because now we have another data point, we can do a number data point, we can do a regression. Let's see the results. Where's my, can I get an ANOVA on this? Yep. So there are some differences. So we won't belabor the point with the degrees of freedom, but there's some degrees of freedom are p-value for overall. So this is the overall. Is there a difference? Yep, there is a difference. Let's do the effect details. Let's do the effects test.
So what would we be explaining with that difference in our real life or whatever here?
Okay, so this is interesting. So when we did it as a categorical, it's saying that there is a difference that's created by the interaction. When we did it as a continuous variable, it says there's not. Let's see, I didn't look to see how the book does it. The book does it as a categorical. I'm guessing he's done that well.
So would the difference be, Dr. Berg, if you have established settings at certain temperatures, then it would be categorical at those values. But if you have the ability to select or you're recording actual temperatures such that there's the greater stratification, then that would be continuous.
Yeah, I think that's a good way to say it. It's so a lot of times where you do continuous is if you're doing, remember the difference between fixed effects and random effects? Remember us talking about that? So fixed effects is, as Mia was saying, where we're going to determine what that is, and we say, boom, we're going to send it at 70 or 15. Boom, we're going to set it at 70. Boom, we're going to set it at 125. A random effect would be we're going to measure the temperature wherever it is at the time. And so quite literally, you know, so we have a bunch of batteries out in the field, and we have a sensor on them, and they're going to report at each given point of time what that temperature is. That would be a random effects. And so to Mia's point, so this over here would be more of a random effects. In fact, if we really wanted to do this right, what we would have done was, let's see if I can do this. And I don't know if we'll do this. There's a place where we can do it in this chapter. If you remember doing this, rats, where is that? Is it right here? We set this up as a random effect. Again, using the analogy or example that we were using before, where we're just measuring this. And this given, we're not presetting it, it's just telling us what we want. And this will give us yet another answer because we've put random effects and randomization is good. And when you have a chance to do it, you should randomize. And so you can see that we've got pretty much different results. Let's see what we do here. I wonder, I'm sorry, I'm messing around a lot with this. I can't find it. Oh, there it is right here. So this is where desirability is optimization. So what this has done is it's optimized for you. This goes back to his earlier question. So in this particular case, with the way we built this model, you would pick material 3, temperature 120, and that gives you close to a perfect score for what you want. All right, that was down a rat hole that I didn't want to go to. So that was that example. Where are we? So that was that. And we answered all those questions, so we're doing great. We did that. Let's jump ahead to this, since we're going into the class. So I think you guys have that, how you set up those models, how you run them. Generally speaking, many of the times what we'll do is run those as categorical, unless you're going to do a random effects. Now that we're this far in the course, unless I'm trying to prove a point, I'll have the problem set up so that they're either categorical or continuous, so you don't get tripped up on that, like on a test. So your next question should be, well, how in the world do you set up one of these experiments, right? So we analyze them. How do you set them up? So we're going to go back to our buddy designer experiments. So pick any part of jump to open up. So I'll go back to battery. Actually, here's what I'm going to do. I think. Let me do this. Okay. So we've been through this before. So you go to design of experiments. In this case, you go to classical, and then full factorial design. And you'll end up with a screen that looks just like the screen. But so here I tell you to set the random seed to 542. Don't do that. Set it to this value here, 1, 2, 3, 4, 5. So let's go do that. So we go to the down arrow, set random seed, and there's a random seed, and we type in 1, 2, 3, 4, 5. Oop. 1. And recall what that does is, so now if you do that, that will make all of our machines synced up to get the same results, because we'll use the same random number. It will generate random numbers the same way. And so let's see what it's going to ask us to do. So let's go down. And we're going to do the chemical feed rate one. So we go in and we start typing in here, percent reacted. Oh, you type in 5% reacted. And at this point, you could leave it the same. But if you have bounds, so in this case, they're saying they wanted, I'm going to guess this is 90 and 100%. So we can say 90 and 100%. So why would you do this? Well, you're setting the bounds, and what that tells Jump is don't look at any values that you give me when I actually enter my results in that aren't 90 per 100. So this is driving it to maximize the goal and to be between 90 and 100. And I'm trying to get so I can, have both screens on at the same time. So we can make our life a little bit easier here by, these are all continuous variables now. And we have 1, 2, 3, 4, 5. So we're going to add 5 factors. And they're all continuous. according to this example, and they each have 2 levels. So you click 2, and it adds those 5 for you. That's just an easy way to do it. The other way, you could add 1 at a time, right? Where you continue this in a 2 level. And so we have feed, we have catalyst, we have stir, we have temp, we have concentration, and we have 10, and 1 and 2, and 100, and 20, 140, and 180. Before I do the last one, so you see how in each case, before you put the values in, we had -1 and 1, those dichotomous values. And so all we're doing is basically putting a label on each one of those values. If we didn't do that, it would use -1 and 1 just to indicate that we have, this is our lower level, this is our upper level. And when you go to build the experiment and run the experiment, you would plug this into these values, 10 and 15, 1 and 2, 100 and 120, into your spreadsheet. And you'll see what I mean when I say this. 3 and 6. Okay, so now we got this guy set up. We're going to continue. We want to run randomize. We're going to do 32 runs. How do you think we get to 32 runs? Well, we have 1, 2, 3, 4, 5, each one with 2. So it's 2 times 2 times 2 times 2 times 2, which is 32, right? Or it's 2 to the 5th. Say make table. And so here, here is a table output. So you can see if we hadn't have put these values in, it would be a set of -1s and 1s. And over here it gives you the pattern. And so this is the high value, this is the high value, this is the low value, this is the high value, high value. So what JMP has done in doing this is it's constructed a full factorial experiment for you. And all you need to do is plug in, so you run this experiment and you plug in the value.
So what does the percent reacted tell us, please?
Percent react, so that is your dependent variable.
Okay.
So you're going to set up, you're going to go to your lab and you're going to set up 32 beakers, and you're going to have a feed rate of 15. You're going to put catalyst number 2 in. You're going to have the stir RPM be 100, and you're going to set the temperature to 180, and whatever concentration is, you're going to have that at 3. And then in the next beaker, you're going to have a feed rate of 15, catalyst of 2, stir of 120, temperature 180, concentration of 6. And what this is doing is basically putting everything into a hat, you know, all these values in the hat, and shaking it up, and in doing the randomization. And this, what full factorial does is it looks at all the possible combinations and provides that information for you. All right. And so your pattern should look exactly as mine if we did everything right and put the randomization in. Is anybody's different than this? Just out of curiosity. Okay. So if you're going to do a full factorial experiment in your project, that's how you'd set it up. And so this is this is the output of that, which looked the same as, if I remember right, what my previous one was. Do I want to do this? Let me look at what problem 511 is. I'm gonna make it easy on you guys. I might not. I don't know. Did I tell you I'm going to publish the test today? Did I tell you that? For chapter, all the chapters up to 4.
You said it was easier than the homework.
It is easier than the homework. I haven't made the test yet, but it'll be easier than the homework. And just like the homework, you have until not this coming Monday, but next Monday to do it. And it's all open everything. So this is the same as the one that I had us do right before break. So let's skip that one in the interest of time. You all know what you're going to be for Halloween?
Giving out candy?
I'm gonna be the grumpy old man on the corner.
Yeah.
I'm with Rob.
I don't know if we're giving out candy or not. I haven't been told yet. All right. So we have a situation. They've discovered a nuclear waste site somewhere on the Oak Ridge Reservation, and what they found there is effective snail, a group of snails that had been mutated by the radiation, and they have like chronic rabies. And also the effect is that it's changed the musculature, neuromuscular interaction, so that their turbo snails can run up to 10 miles an hour. And just like zombies, they have an insatiable appetite for human flesh. I don't know, did you read that on Fox News? I got that on Fox News. Nice kid. So let's open up Jump and see if you can build this on your own. We're going to do this instead of the other one. So let's see, let's race to see who can build this the fastest. So you're going to Jump, and we'll do this full factorial. So we'll see if you can build it. We won't worry about matching the random seed. So this is a do on your own. So go ahead and plunge ahead, see if you can do this on your own.
I believe if you keep it covered up, you'll win.
All right, here we go.
So are we setting the seed for that?
No, we won't worry about that.
Okay.
Which I'll end up with. So it look like something like that. Yes, no. What happens if you make the table? What does it look like?
I have problems with it responding for the change in the material type. So it was to put it as continuous instead of,
Oh, really?
yeah. But I think that's my input, you know what I'm saying?
It could be. Okay. So you will end up with something that kind of looks like this. Oop, sorry. So I'm not going to talk about center points today, but if you, well, I'm not going to go in detail on center points today. I'm going to show you center points. Let's just do this. Crap. Let's do this.
So you can mess that up by doing what you just did right there, right? And put continuous versus categorical.
So I wanted to put in categorical so I could put in center points.
Sure.
I mean, continuous to put in center points. And so what doing center points does is, so jump assumes that there's, when you build it, that there's nothing going on between the 2 points in terms of changing the curve. And by that, I mean, so if you have, say, two levels that you put in there, jump is assuming that there is a line that's straight between these two. But what if there's not? Right? So what if in the relationship between the points, it actually goes like this, which could very well do, right? I mean, there's nothing in nature that says that between 2 points, there's no deviation off a standard slope. So what you do is you put in center points. And what jump then does is it builds your model to actually put in a center point for you sporadically, but in a statistical way, so that you can start getting an understanding of, does this curve actually, is it actually straight, or is it something like this, or this, right, or this. Oop, sorry. This. Between these 2 points, which is an important thing to know. The reason you would or wouldn't do that gets back to the economics and other factors of actually running the model. Do you have enough time or materials or other sorts of things to actually do those center points?
Do you have to have it set at 3 levels in order to do the center point?
No, that's a good question. I just put in 3 because that's what my cursor fell on. So you could put 2 and we put center points in. Good question. So this is what that's saying, right? So this puts center points in, and had we not put center points in, so say this wasn't here, it would say, well, there's a straight line between the two. What this is saying is that as time's going on, we have an increase and then a decrease at the end. So we have some sort of effect where in between, say it's a reaction rate, and the reaction rate, as you use your reagents, your chemicals up, we have an increase, and then as they get used up, the reaction rate goes down, right? Or this could be drug efficacy over time. So so on Halloween, you celebrated a little bit too much, and you took Tylenol next morning, and the content of Tylenol in your bloodstream at 10 minutes was this, at 20 minutes it was this, and at 30 minutes it was that. So if your question is when do you use that, in situations where you're uncertain what the effect might be and if it's changes over time. I think I'm going to stop here today. So that give you time for questions. We can chat a little bit about the test. So the test is going to cover 1, 2, 3, and 4. We won't cover chapter 5. It will more than likely have some multiple choice or true false or short answer sorts of questions, kind of the theory sorts of things. And then it'll have a small handful of problems to work out. And between Abraham and me, we'll figure out how to get partial credit if you're doing it. I'll set it up so that there's not an issue with worrying about categorical versus nominal versus, or rather categorical versus continuous variables. So it'll include things, so it went up through blocking, and so it'll include probably a couple of flavors of blocking in terms of the problem. And that's it. Should be pretty easy to do. Make sure you do all those adequacy checks that you need to do. Make sure to include the interpretation of the analysis as part of what you're doing. If there is a problem on there that has you do the design of experiments, which is going through this thing, right? If we do, oops, a Latin square, say, make sure, if there's a random seed in there that you set the random seed. Like I said, it's all open, everything. The only thing I ask you not to do is, so unlike with the homework, this is a do-it-yourself kind of thing. So is there any questions?
So if we do have questions, can we send them back through you that we normally would have maybe talked with classmates or whatever?
Yes.
Okay.
And what I try to do with the questions is either take them out of the book or find another book so that they're well developed. I've learned the hard way that coming up with, I think, a really creative, novel questions usually results in a challenge because they haven't been vetted by a lot of people reviewing it. And it can be open to misinterpretation, which is not good for a test, right?
Is this test going to be on Canvas like the quizzes, or is it going to be like a assignment that we turn in with a Word document?
That is a good question. It's going to be one that you submit via Word document. I think Canvas can be, while it's easier to grade via Canvas, I think it would be, it's harder to get partial credit on Canvas. I'm not going to use kind of like the Canvas quiz grading kind of thing. So Ibrahim and I will be grading it manually, and we'll get. So this is for Ibrahim. We'll get those last assignments graded into you really quickly. Hopefully Ibrahim has time like today and tomorrow to do that. Ibrahim, I'll get you the answer key so you can do that.
Yeah, I'll do that. Thank you.
Okay. So are we good?
How much will you count off if we use simulated data for our final project?
Nothing.
All right.
You just have to, I mean, so this is, I'm going to state the obvious here. Well, let me take that. So I'm a real proponent of simulated data, but you gotta come up with the justification of why simulated data is an appropriate exemplar of what you're doing, right? All right. Yeah, my whole thesis was based on, well, that's not entirely true. A big hunk of my thesis was using simulated data. I did a clinical trial to validate the simulated. I'm not saying you have to do that, Blake, but yeah, simulation is good. Anything else?
Will you go over that final, the final 2 days there? I think Blake might have missed it, and I'd like to hear it again. We're talking about
Oh yeah,
removal of the second test and the final, or the
yeah. Everybody wanted a third test, and I was saying no, that doesn't seem fair to me. In fact, why don't we only do one test? And they didn't want to hear it, but we ended up with a compromise. Are you talking about that, Joe? No. So this is the calendar for the rest of the semester. And so this is wrong. We're actually on the 23rd today. And I was talking about, we have an option. So I completely forgot that we don't, this is Thanksgiving break, so we don't have class on the 27th. And so our actual time to present present the projects and turn in the final project document is the 4th. And what we're talking about is, would the class be interested in having the final presentation be the 20th? You know, I was planning to have 2 tests this semester, which would mean that had we kept it the way that originally was, where the 4th was the presentation, then the test would have been due on the 20th. So now what we decided is that there's no second test, that the presentation is due the 20th, and the final project document is due the 4th. Okay, so let me just make sure I got that straight. No second test. Presentations or do the 20th, and the presentation template as a suggestion. So you don't have to do that, but a suggestion is in the module at the very bottom below module 5. That's the 20th. And then you turn in your papers on or before the 4th. There's a template for the paper too. There's also somewhere in Canvas, probably 20 different example projects that can also serve as templates for how to write it up. And as you look at that, you can ask questions and that sort of thing. No homework this week, obviously, since there's a test. So we good? All right, so you get a bio break before Mr. Stevens gets a hold of you. All right, y'all have a good weekend.
You too. Thanks.
Thanks.
Hey, Craig.
Yes, sir.
I still don't have any grades posted for this class. I was wondering if there was a holdup in that, or
Yeah, I think I went through most of them, and I think the only thing that's holding it up is some kind of button that's not been pushed. You know, something that's not been submitted somehow. So, Omkar, is he on yet? No, doesn't look like it. He'll have to help me make sure that that gets out. But
Okay.
I appreciate you telling me that, because on my side, it looks like it's all been done, and I'm a little bit confused on what I need to do next.
Yeah, so I think we had the same problem with Dr. Berg, and he said, "Oh, I must have not clicked something." He clicked something, and it finally showed up. So,
And who's that?
do what?
Who was that?
Dr. Berg and Design of Experiments.
Okay. I'll reach out to him and see what he did. Yeah, I don't know why, but you know, the bottom line is just if you're not happy with the grade and it looks like you missed something, just turn it in and I'll update the grades. And so far, if it looks like you've gone through everything, I clicked on it. If you didn't do the quizzes, then I didn't grade it yet. So just turn in the quizzes, and those quizzes are nothing more than all those answers on the back of the book, back of each chapter. Just turn those in. All the answers are there. There's no way you can miss it. If you miss them all, if you miss 100% of those and you go back and look it up and find out, you still get 100% of the points, because all I want you to do is just get used to taking the quiz and so if you can prove to me you've gone through it all, then I'll give you credit for it. And up to date, up to this time, if there's anything turned in late, I won't count it against you. And if I did for some reason, because early on I started grading a little stricter. So if I did, just reach out to me and let me know, because I'm more concerned that you guys are getting a tool that you can use and you're doing all the work than I am that you're doing all the work perfectly or turning in time perfectly. A couple of people had some other issues with work and travel and that kind of thing. So should be pretty easy. Now on the midterm, if you turn in a couple of pages, that's not really what I'm talking about. You got to show that you put in a lot of effort in putting this together, not just 2 pages of outline, for example. You got to show me. So keep working on that and make sure you're making progress, and you can update it if you want.
Yeah, I think we're all anxious to see our grades on that, so we're looking forward to that.
Yeah, if you turned it in, and it looks, if there's any question to it, just keep working on it, because it's really more of a tool. But I had to grade it somehow as far as, a midterm or a final. That's how we counted those. But it's really just, I want you to have that tool. I want you to, next time you go somewhere and you say you graduate with your master's from UT, I want you to be the best you can possibly be.
What about the discussions?
Yeah, discussions, just make sure that you're talking during class and you're talking, you're putting in comments and interacting with people, and that's good enough for discussions.
But they were locked yesterday for chapter 8, and they were open till Monday for chapter 7. So I thought all the due dates have been moved to Monday.
All right, Omkar, did you hear that? We need to make sure that there's a place for the discussions for every chapter.
Oh, there is for 8th chapter. I guess I'll open up the discussion chapter for chapter 8, the page. And Armin, can you give me just 5 minutes, because my Zoom app is not working properly. I'm also working on the second chapter thing. So Armin, please give me 5 minutes.
Okay. And
Yes.
Also, if you would help me figure out how to release all the grades. I think I submitted them as I was going, but obviously I'm doing something wrong. So if you can kind of guide me through that so everybody can see their grades, then that would be wonderful.
Yes, surely, Professor. Just give me 5 minutes. Armin, 5 minutes, please. Sorry.
Yeah. Well, we can talk about it after this class. So, but I want to make sure everybody gets it, and just reiterate, if there's something missing that I drew attention. For example, if you went through and did most of the exercises, but you left out one, I'm thinking that's an oversight, but I still graded you as if you didn't turn it all in. And so if you turn that one back in, resubmit it, let me know about it, then I'll go in and up the grade. Because like I said, I want you to pass this PMP if you're going to do that. And I want you to be superstars when you graduate from this program in project management. That's my goal.
Yeah, I want to point out also that some of these discussions have been hard to comment on because they have such crazy dates. Like last weekend, we had chapter 4, 7, and 8 come online to make comments. And I didn't realize that chapter 4 and 7 were only open 2 days.
All right. Well, yeah. Omkar, if you would just leave those discussions open, then I'll go in. And if you, for some reason, didn't get one of the chapters, go back and look at it and talk about it, then that would be helpful. And I just don't want you to be penalized for the system errors we have, either trying to learn the system, learning curve, or just something that wasn't set up correctly.
Thank you, Professor.
Yep.
Just 1 second. Admin, can you please assign me as a co-host, please?
All right. I'm gonna go ahead and start. Are we ready to start? Everybody back, you think? See the thumbs and I'll see. All right, see faces. Roy, you need a shave, Roy. You're looking like you got, there you go. All right. That was Rob, that was kind of hypnotizing, I think. All right, so we're in chapter 9. This is week 10, and chapter 9 is all about resource management. So let's, and I'm going to go and do like we did all the other stuff. We're going to look at the concept phase, which is not covered in PMP, but we're going to talk about it. And we're going to go in planning and then the actual implementation phase. So these are the 2 areas that this resource management chapter covers. But I always start off with concept. Resource management is going to look at the point where we're actually managing the resources. It makes perfect sense, right? So if we look at the iron triangle, then time, cost, and requirements, right? So we went schedule, we looked at cost, we looked at the quality, right? So that kind of covers these. Resources is that thing in the middle. So if you were to get on the test and you wanted to think about, well, what comes first, what comes second, what comes third, then think of it in a logical order. If I'm trying to, let's see if I got the next stage. Well, we'll talk about that in a second. Let's see if I have it. Well, we'll have to talk about that when it comes up. But so think about how you're going to lay that table out, right? Because that's what you can do. You get paper, you get pencil, and you can lay it out, and this will help you think about each of the sections of the exam if you're going through a PMP. So in resources, one of the natural things when we talk about resources, we think about people, we think about team building and everything else. But when you add people, you're really adding leadership because that's your job to lead people, right? And then if you're thinking about leadership, you're really, and people, you got to think about culture because that's the one thing that will help your organization, your project improve is creating a really good culture. When I go into a project, I always tell everybody, I say, my number 1 job is make everybody look good. I'm trying to make my people look good, my team look good. I'm trying to make myself look good, right? I'm trying to make the person I'm working for look good because they look good because they hired me, right? And I'm trying to make them look good to their boss, to their customer, and everything else. So if you approach it that way, then you're not going to stir up a whole lot of conflict. You're going to say, well, all right, what can we do to get out of this mess? And so who caused that mess, right? And then you may have to adjust your team. You may have to get rid of people, right? You may have to be hard on some people, but you want to do it in a way that they save face. So if you have to remove them, you don't necessarily want everybody to know, well, that problem's that person's fault and they're out of here. You want to just say, well, we, solved the problem, whatever the case is. So when we talk about people, you really talk about a lot of different things. So now let me go back one. So I want you guys to tell me whatever other things can we talk about when we talk about resources? Outside of people, what are the other resources? So I'm just go down the list. I'm gonna go down. Michael, give me some good stuff related to resources. Other than people, what are resources? Just name me one.
Parts and equipment.
Yep, exactly. And so we have that coming up. How about Dylan?
I got one. Information.
All right, information, that's a great one. And that's one people won't necessarily think about, right? Unless you're in IT, unless you're in the modern era, but data and information is a big thing. All right, give me something else that's resource oriented. That's a resource. Eric.
Infrastructure.
Infrastructure. So what do you mean by that? Because that's a broad term, means a lot of different things, but.
Well, everything that builds your facility, the labs, the work areas, but also like the information technology infrastructure, the networks that you use and all that other
You
stuff.
know what? You just covered everything else, I think. Can anybody think of anything else that's outside of that? So we got, well, maybe there's one more thing, because I know, Michael, you said equipment. Eric said resources. What about materials? That could be, I mean, infrastructure. What about materials? That could be something outside of infrastructure maybe, but the flow of materials is definitely a systems approach, an infrastructure approach. So that might be something else, right? And so there are probably other things, but if you think infrastructure, people, equipment, materials, if you think like that, then you're thinking along the right line. But what we're going to
Would
focus—
time be one?
Time, let's see. Time is definitely related to schedule. So when we talk about resources, we're probably going to put time under schedule. We'll probably put cost under schedule, under cost. And so it'd probably be a little bit outside of scope, but I could be wrong. Okay, so it may or may not be. So this is one thing we'll talk about when the time comes up, but this resource breakdown structure, this is kind of like the work breakdown structure. And there's also two different RBSs. One is resource breakdown structure, and oftentimes people call a risk breakdown structure. So RBS, WBS, RBS twice, could be two different RBSs. So you have to be pretty careful that you're talking about resource breakdown structure or risk breakdown structure. And, different companies call them different things. So you see that here, there's the people, there's the material, there's the equipment, there could be infrastructure. And Eric, I was thinking about labs too. I was thinking about, that's what I was listening for, labs and shop floor and those kind of things. So that's kind of what this area is about. You're trying to make that happen. So tomorrow, next week, we'll talk about communication, and we'll talk different types of personality types and those kind of things. So even though that's related to people, we have a whole chapter on it. So let's leave that for next week. So we're going to look at motivation. Yes, sir.
For the resource breakdown structure, does that look any different when you're sharing resources across projects?
That's a good question. I don't know if I can actually answer that. Let's see. Let's go. So you're going to share people, right? And you'll probably share material. If you're building houses and you have a bunch of different projects going, you're probably going to the same. If you stored sheetrock, for example, you'd probably share it in a whole bunch of different houses. You'd probably order in bulk, equipment, you definitely would share equipment. If you had backhoes, you'd probably have a time where you use a backhoe and then a time where it's not being used. So if you had 100 different projects going on, you're digging foundations, you could share that. I think that as far as we're concerned, we're looking at the resources we need for our project. If we're the program manager and we have 100 projects under this program, let's say we're building a subdivision and there's 100 houses being built, then I can see that the program management resource breakdown structure might include, all the different projects. But now we're getting into a little bit bigger subject, program management instead of project management.
Thank you.
So that's good. That's a good way to look at it too. So to answer your question, probably, but we're concerned with our own project. We're the champions of our own project in this case. So all of that other stuff is important. What we're going to spend all day, all this class on is just motivation and productivity and team building, conflict and that kind of stuff. So we're going to spend all our time here, which is the biggest part of that. People's biggest part of anything, usually. All right, so successful teams checklist. I came up with these from somewhere, I don't remember, but usually how this works is I either read it in the textbook, I read it in the PMP, I read it on other books, and then I start putting things together, and I usually tell you where I found it. So in this case, I probably put a collage of things together. So this is step one, get your own act together and build your own core competencies. That's what we're doing now, right? We're trying to train, learn, create all these tools, and we're doing that long before a change happens. And this is kind of the forgotten phase. Get your people up to speed, get yourself up to speed, build your own core competencies and do it before the project begins. All right, so next one is understand the game, but we'll get to that as we get to it. So resources, this is the 3 different areas. There are going to be 7 different parts to that. We're going to go over those, but what I'm talking about kind of bleeds in and out of all of these. So we're going to look at the planning phase, the implementation phase, as far as phases go. And remember, this is artificial, could be called a whole bunch of different things. It's not part of the PMP test. They're not going to say everything has a concept planning implementation phase, but everything has a life cycle, right? So your company may call it different things. If you're in IT, you may use all kinds of different, IT has so many different life cycles. I don't know if anybody's ever documented them all, but there's so many different variations of it. Process groups, initiation planning, so we know what this is. This is actually what they call these process groups. And even though I would consider all this more along the implementation phase. So that's just a reminder. So now let's go into planning. Planning phase, if I were to design the phases, I would say, well, there's a forgotten phase. That's getting up to speed, being the best you can be, getting all your tools together and everything long before you even know there's a project. And the operation phase is long after project's gone. This is what you're doing, right? So concept, planning, implementation, and transition, just a reminder. So we're in planning right now. Planning has to do with scheduling, budgets, resources, risk, and staffing. Staffing and resources could be the same thing, right? So we're in this planning, could go on through the concept, it could go all the way up to delivery, but that's what we're doing. We're managing this planning, of what we're actually doing. All right. And then planning, we talked about this a bunch of times, but this kind of the project management life cycles can go into problem solving and task and projects, and it's all kind of similar. And here's where we are. So now we're in the planning phase. We're in the planning process group. We're under the resource knowledge area, and this is where we are. So the first thing that PMP tells us, and the PMBOK guide tells us, is there's input, tools, techniques, and outputs, right? So this is all old news to you guys. So we have the charter, we developed that early on. We have the project plan that we're working on, and we're going to keep adding to it. This time we're looking specifically at that. We have other project documents. We have our culture and everything we're dealing with, all our company environmental factors, whether they're inside, outside, it's all kinds of stuff, regulations. And then we have all the process assets, operational process assets, organizational process assets, I should say. So now we're going to use our expert judgment. You're using data, you're using organizational theories, we're using meetings, and we're going to come up with a resource management part of our project management plan, right? So this is that tab, or could be a whole set of document in itself. And then we're going to come up with a team charter, and we're going to update our project documents as we go along. So that's kind of what that goal is. This is all under plan resource management. So if we go to McCahey's page 364, then we're looking at the plan resource management part. And these are what I think is she highlighted, and that would fall in this area. So determine planning team, who's going to help us plan. And then if we look at her book further, these are key concepts for resource management that she laid out. So if we're looking at creating a resource management plan, we may want to think about these things. What's the team environment? Where are they located? Are we all on Zoom calls because of the situation? Are we all in one building? Are half of us on site and half of us, back somewhere else? We have to think about that. Communications among stakeholders. Next chapter, we're going to go in great detail that, but that's part of the resource plan too. How are we going to communicate? I remember one time I had to create a series of, I had to create rules for communicating, because if you're with a group of people and somebody doesn't like someone else, they have these sniper attacks, right? So they'll send out this email and they'll blast it to everybody and they'll say something nasty. Have you ever been in that situation where you've seen that? Everybody on your team gets this nasty email. So after one or two of those early on, I learned that I put together a rules and regulations, conduct of operations for just communicating. And so I said, if you name anybody on that email, copy them on the email, right? And that cut out a bunch of stuff right there. If you send out an email to the customer, you can't do it. You got to go through the project manager. So the project manager we have a single point of contact, right? So don't do that. If that happens because you got permission, I want you to CC everybody who is named in that and anybody that's providing, resources to them. And everybody knows rules. Nobody reaches out except for that one person. There's no blast to everybody on the CC list. And if here's how you use blind copies, here's how you use CCs, and here's how you use this, so we had to go through that whole process. If you're angry, call them first. After you call them, meet them in person if you can, and then you can send an email if you can't solve it to me, and then copy me on that, that kind of thing. So I had to go through all that stuff just because there's conflict and people, if you ever experience that, it can get out of hand, right? So that's supposed to be organizational change management. And anyway, so I typed these things in pretty quick. Internal and external policies. And so all this kind of stuff you're thinking about when you're putting together the plan. And so on page, on her page, let's see, what page was that? Anyway, Rita's McKay's page. Yeah, I think it is 369. She went over she talked about something related to plan resource management. And so this is a pretty good list. What resources are required? And I went down, you can read that later, but it's in the book. And so maybe this looks like a pretty good outline for the resource management plan. So when we get a little further, I actually found something else related to that. And I added this. So the way you can do this is you can look at, well, we're going to be in certain stages like define, design, build, and display. Anyway, so we're going to go through these stages. Could be concept planning, implementation. It could have subparts to that. We can always divide these into those two. And then this is who's going to do it or what function's going to happen. And, so they're planning some of the resources that they need along the way. So there's other ways to do it than, document. I would create a Word document with all the information in it, then I might have a bunch of tables in there. All right, so now the next one is estimate activity resources. So under here it says project management plan documents, enterprise, these things are in everything. Matter of fact, this is in a lot of stuff. Expert judges, it's in a lot of stuff. And every time we start estimating, there's bottom up, there's, what does it look like compared to something else? There's, parametrics of the project management information system. That's I can't remember, that's in all of them, but that's common too. And that would be like our Microsoft project server tools, or it might be Microsoft project software, that kind of thing. Something else we did, right? Requirements. And then basic estimates, resource breakdown structure. That's where we're going to go back and visit that. And then project update of documents. If we go to Rita McKay on her page number 364, then this is what she has highlighted. And I think it may fit into this category. they're a little bit harder to fit them together because they overlap in more than one place a lot of times. So,
Oh, Julie. How are you?
yeah, you're not on mute. Tim, is that you? Tell Julie I said hi.
Talking to my dog.
That's pretty awesome.
That's right. So this is let's see. So remember, we did this already, right? We came up with a list of things. We actually estimated how much time we thought it would take, and we should have thought about the resources to apply that. But here's where we go in, and if we had Microsoft project, we would go in and actually put names into a column, over here somewhere. It'd be one of these columns, and then it would sometimes it actually puts the names by the Gantt chart. Here the red sometimes represents critical path, and sometimes it doesn't. It looks like this might, and so we're actually at this level. We're looking at task per task per task, and we're thinking about how many people, what type of people, what type of resources, what type of material, what kind, and like Eric said, what type of infrastructure, and Michael said, we're looking at all those things: equipment, machinery, all the stuff for each one of these, and now this is what we look at. This is a tool. It's called a RACI diagram. It's RACI. So how many people have heard of RACI diagram before? Give me a thumbs up. All right. So Rob, I see you. And Michael, I see you. And I'm looking for a couple others. Mia, are you there? Yep. So I figured you guys would have seen it. And Blake, I see you. So this is a cool document, right? It's just a spreadsheet. And I actually have these. I'll put these, eventually I'm going to put them up on that app that I told you about. So if you want copies of these, I'll put them up. What I'm trying to do is I'm trying to scrub them a little bit so it takes out the personal information, who it was done for and those kind of things. So here's an example. Our process responsibility, improvement responsibility, they put 2 here. And then A is process accountability. C is they consult on this, and I is inform. So if you see this, there's usually only one R. There's a couple of A's in some cases. There's a couple of C's, different places. But if you have, let's see if I say that right. Yep, a couple of A's. So under different things. So these are the task, and these are people sometimes. Make sure. Sometimes it's set up differently where there's people and tasks. But in this case, it looks like these are the people and looks like these are the tasks. So now this person has this responsibility and these responsibility and this responsibility, right? So this person has this responsibility. So this one person, this is how they fit in. This one person, and sometimes, this looks like a group. So sometimes this looks like, well, we got to inform them here and they're accountable there. And, that's what that looks like. So this is one way it looks. Here's another one, right? So there's an R and an A and a C. And there's your company can come up with their own method, right? So although there may be one right way, when you add your company's name into it, then that even changes that. There may be more than one right way, and whatever your company does is the right way until you change that process. So Rob, do you agree with that? So have you seen, Michael, Mia, Rob, have you seen, do you have any insight that you can give us related to that? Or Blake, I noticed you said you saw it too.
Yeah, I think I've adapted this multiple times to multiple customers based on their culture. Yeah. The common one is, some clients I've worked with, they believe that there should only be one person who is overall accountable. Yep. And you can have multiple people responsible. So rather than have that holy war, I just flip them.
Yeah, and that's that's what threw me, because I've heard that also, and it depends. You notice when I hesitated, said, well, in this case, there's one person responsible for things, and so there is a little bit of confusion. And what you want to do is you want to make sure that your company, you do it the way your company wants, the way your PMO, if you have a PMO, the way they want to do it, not necessarily the right way. I never have that argument. I say, well, I might have the argument like, let's see, Rob, this is exact. Well, there's two A's here. There's one R, and I should look at it a different way. So there's two R's and several A's. It gets confusing.
Yeah, that one I would have some problems with, because you either have to have one person accountable or one person responsible for each one of those areas and or each one of those tasks, and then be consistent.
Yeah, and that's a good point, because you don't want too many chiefs, or you don't want too many chefs in the kitchen, that kind of thing. You gotta have somebody that can make a decision. In this case, PMO looks accountable and project manager looks responsible. So, the project manager oftentimes reports to the PMO. Sometimes the PMO is just an oversight, so that they don't necessarily have project managers, the division managers. So it all depends on how the company's set up. Here, the person who is, here's the definition of that. And this is the next one we're going to show. So RASCI, they added an S, right? So this is the person who's responsible for gathering all information from various sources and producing deliverable. There can only be one person responsible. Okay. This person who is accountable for approving a final deliverable, accuracy and completeness, there can only be one person that is accountable. So here, Rob, this particular company likes to do it this way. So that's the reason I say, don't get bogged down on what's, the one best way to do it, because before PMI came around, before there was a PMBOK, there were thousands of ways to do this. Matter of fact, in one company, when I first worked at SAIC that long ago, there wasn't a PMO. There wasn't one way to do project management. Everybody who was a project manager had their own system. And me being an industrial engineer that was systems engineer, basically, then I was thinking along the lines of, there's got to be one way to do this. And so I would have my one way, and I would share that with other people, but that's how far back it goes. Now, almost everybody has a systematic, repeatable process if they have a PMO in their company. And that's what you learn what they do. Support, the person or persons who assist in completing the task. I don't know, because sometimes that's left out. Consulted and informed, that's just the way to look at it. So there's this chart from this company. So let's see if we can look at it. They have approvals up here. They have task list here. They have all the names of the program manager. So these are general names, but you can get specific names. You can say Blake does this, Roy does that, Rob does this for these particular tasks. What I found was very successful when I was working with Department of Energy is I would have one person responsible for a task, and I have a whole bunch of people supporting that person. Then I'd take one of those support people and they'd be responsible for another grouping, a task. And I'd have, that way people would support. For example, if the project was big enough, I would have each of you be a mini project manager for a grouping, a task, right? And then I would have each of you support the other people. So Blake may be the project manager. I'm using that term really loosely for putting out the public information, and then Rob's really good at that too. So I'd have Rob be his second, Blake and Rob have to agree with this, right? So Blake would tell me, well, if I'm in charge, I want to know who my second is. And then there'd be three people, maybe Lucas, Dylan, and Michael. You might support them in that. Where on the very next grouping, that might be research on the best way to do something. That might be Michael's in charge of that one. Tim is his second. And then there's 2 other people that supporting them. And by doing that, everybody had something they were in charge of, and everybody had people in case they had an emergency, their kid went somewhere, that person that was second had to know what that first knew in order to manage it further. And those people that support, and they work together in little bitty teams that way. So teams within teams. All right, so that's the first part under planning. And now we're going to get into the heavier stuff. And when I say heavy stuff, I mean the softer skills, and that's related to people. So here we have, we're actually acquiring resources. And so we're going to think about where we're going to get these resources. And here's what we're going to come out with at the end. We're going to have physical resource assignments. They're going to have project team assignments and all that kind of stuff. So we're acquiring resources. This is a couple under McCahey, and let's see if we can make heads or tails out of this. So now we're going to the Gantt chart, and we're trying to do resource loading is a little bit what fits in this category too. So let's see. All right, I'm just reading some of the chats that came in. All right, so let's see, and we saw this last time, but I don't know if we spent enough time on it. So here you have task 1, 2, 3, 7. We have the actual person, let's say task, yeah, let's see tasks. So we have the person in charge of those tasks, and let's see, 6 people, yep. And then what we're trying to do, yep, there's people there. So that's people there, and these are the tasks up here. So there's a person 2, person 1, person 1, person 2, person 2, person 1, person 1. And so last time we said, well, we're talking 100% of effort, so we don't have 200% of person 2. And that's, we load up the chart. These are our project task, right? These are the people doing that task, and this is just the time. So that's time, like month 1, month 2, month 3, or week 1, week 2, or day 1, day 2, something like that. So I got it right this time. So let me look at, this is the person, this is a task, and this is time. And so if we look at it, we know that if we had to shift this person over, which shifted our whole time, 1 full unit, right? So that could be a month, a year, a day, whatever that unit is, an hour. And so that's the way to do it. And then last time we talked about this a little bit. This is what actual resource we have loaded if we just looked at the Gantt chart, but that doesn't exist in real life. So we have to level that out. And so by leveling it out, it creates, more of a time. For example, we're going to end here, but by leveling it out, we got to push that time out past this point. Give you an idea. Makes sense so far? Let's see, we're loading up the resources. What we really want to do is have something look fairly smooth that we can handle. We can ramp up pretty fast. If we can't, we got to ramp up slower, right? And if we ramp out slower, that may push us out further, and we could turn it over pretty fast, but chances are we may have to ramp down slower too. Because what we don't want to do is cause problem for our company and cause problem for the people who may have a charge number that they have to charge. So we may lower it a little bit and add, more time at the end. But, we got to balance all this stuff. All right. And so it may be that that's too steep of a ramp up for us. That's too steep of a ramp down. So we're going to try to figure out what we can actually do with those resources. Maybe if we can't, maybe someone else will need that piece of equipment at a certain time, and we can't just get it to them overnight. Maybe it takes a ship across the country or something like that. So you got to think about those, and that will have an effect on your cost. It'll have effect on the timing and everything else. Originally, we just thought about scope, and we got it all set up, right? And we thought, well, in the perfect world, this is what our scope is going to look like with our schedule and our cost. In an imperfect world, this is what our schedule will look like. We got to take into consideration, this is the rainy season, or this is the middle of winter in the Arctic, wherever we are. All right, so that's modified time smoothing. And directly related resources. It may be that this is all the people we have. This is how we have to use them. Now we need some kind of service provider. So we may have to hire vendors from outside just to make this happen in the amount of time we have. All right, so now we're looking at develop team. So develop team, it's all about managing people, and the rest of it overlaps a whole lot. So we'll get into that. So let's go into team building. So team building, successful teams are not huge. They're not hundreds of people. They're smaller in number. Now you can have several different smaller teams, but really it's hard to get a large team to work together. It's when I do facilitated problem solving and say we're trying to improve the flow of your process, right? If I get 10 people in the room, we're not going to make any progress because 10 people argue all the time. But if I can get 3 people in the room, then I can get the next 3 people in the room, and I get the next 3 people in the room, or break that last 4 up into 2 or something else, or even let them overlap a little bit, get 3 people and overlap with another 3 people and overlap. If I can do that, then I can make progress fast. Mia and Michael and Rob and whoever else wants to add into it. Have you seen that? Have you seen a large team cause you more problems than you expected?
All the time.
Yep.
We make decisions by committee.
Yep. And so, the tool we looked at last time, that one-to-one comparison, is a team tool. If you had 10 people in the room and you voted on what needs to go there, then you're going to have a little bit of problems, but you're just going to solve arguments and conflict by just putting both of those little numbers down to come up with that weighted average. But it's, it gets terrible. I mean, it's really bad. Mia, I think you were going to say something.
Yes, I was. So if you can center the conversation around the actual process, sometimes, many times, that conflict is good because it's indicative of, it's indicative of the lens through which each one of those people is viewing that particular situation. And they could all essentially be correct relative to that perspective or where in that value stream they're focused. So if you can draw a process map or provide some sort of visual and talk through the entirety of that process, then that a lot of times I've found helps to give everyone a more broad perspective and helps you to see truly where the interactions are, the handoffs are, and typically that's where your variation, your challenge.
Yeah. And so to add what Mia just said is that if we had 10 people in a room doing and I'm just adding to it. So you may have meant something a little bit different, but I'm adding to that, my thoughts. So if you had 10 people in a room, you're going to have 20 different ways to do that. Right. And so your goal in solving that problem, seeing what the process is get everybody's mind on paper. So with 10 people and 20 different possible processes, and that's an exaggeration, it could be 5 or it could be 6 or it could be, but there's going to be multiple. And if you get 2-3 people in the room that have been doing this for 20 years and you ask them what they do, you're going to get 3 different pictures at least, right? But they're probably going to be, well, it depends because at this time I do that, this time I do this. So the bigger that group is, the more conversation you have and the less likely you are going to come up with something the first meeting. So what I found is that if I can narrow that down to a couple of people, get their mind on paper, take that picture to the next small group, then we can go there and they'll say, yes, no, each of those tasks, and they'll come up. So the key, I guess the bottom line is, look at the number of people to do what you need to do, and look at both their their subject matter experts in different ways a lot of times. So sometimes they complement each other and sometimes they contradict each other and sometimes there's conflict there. But smaller teams, a good way to solve that blockage is to think smaller. And think like we're going to look at, instead of this broad process, we're going to look at this step in this process, and we're going to fix those problems at a time. Anyway, we could say a lot more on that. So why Teams? Well, I think you guys understand Teams, but we're promoting the work in a way that creates the weaknesses. It's kind of like that performance measure thing we talked about. Each one of those links in the chain, well, we're trying to create not a weak link between people. We're trying to work together as more of a cable. So we cover each other. Cable would be a little stronger than that one link that may have, may be going through a bad day or something like that. So we're trying to create a way to a little bit of synergy, 2 heads equal 3, that type of thing, but also a little bit of a way. And I think we talked about, see, I do webinars too, so it's hard if I talked about all these things, but if we didn't talk about links, we should have. And so think along lines of each of those people become a cable, one of those cablings that are wrapped together and help you go forward. Teams are most effective to respond to today's business challenges because it gets complicated and all kinds of things. So understand the game, explain what goods looks like. Here is, I have a story go along with this one. Back when I was laid off in Oak Ridge, right? Because I was laid off with like 3,000, 10,000, my closest friends, it's one of those big rifts. And I came to Nashville and I just moved in with my mother because I was going through a divorce and all kinds of things. And so I was looking for a job in Nashville, living out of my mother's condominium, and paying her rent and all that kind of stuff. But I said, well, what kind of technical stuff is going on in Nashville? And so I couldn't find a whole lot that related. And the one things I did find I was overqualified for. Everybody kept saying, well, you're too qualified this and whatever. And so I went to Vanderbilt University and said, I want to teach your classes. I want to teach on project management. And I was working part-time for NASA and part-time, about that time I was working part-time for NASA. And I was working as a facilitator for the American Management Association. Here we go. I get this all the time too, Mia. And so in the process of going through all that, I went into Vanderbilt University. And I said, I want to teach your classes. I know change management, I know project management, and I know this stuff, I'm industrial engineer, system engineer, I'm working on my PhD and all this stuff. And then the head of the department put his arm around me. This is the chemical engineer. No, this is the computer science and electrical engineering department management technology program. So management technology was under that department. And so a guy basically talked to me a little while, put his arm around me, walked me to her, says, Craig, first we got to know who you are. Then we got to want you to teach here. And then we got to have something for you to teach here. We got to have a spot for you to teach here. And we don't know you. We don't know if we want you. And we don't know if we have a spot for you. And so he walked me to the door that way. And so I've always feeling rejected and all that kind of stuff. And then when I got home, I had immediate answer, voicemail on the answer machine at the time. That's how long it was. And they said, Craig, we want you to come in for an interview tomorrow. So tomorrow I have an interview with a company that said they didn't need me or didn't know if they needed me yet. So I got there and they ran me through the ringer. They said, what makes you think you can teach? What makes you think you can teach here? What makes you think you're good enough to teach here? What makes you think we want you to teach here? I mean, it was very confrontational. And I went through all the people who are teaching, who are the professors there. And then at the very last one, he says, well, has anybody told you what's going around here? And I said, whoa, no, something's going on here. And I don't know if, this doesn't sound good. So one of their professors died. They had several people go through the class and they needed someone else to try, run them through this ringer. And so they were going to give me a chance. They're going to let me teach this undergraduate class and research. And so I said, great, I'll take it. So now I got a job, right? So and I had part-time jobs, but now I had a real job, a real teaching engagement at Vanderbilt University, great engineering school, rated high. It's like the Harvard of the South or whatever they claim they are. So I thought, man, that is great. So I went in and I started teaching this guy's class, and I got real high marks because I took a different approach. But the moral of that story is when somebody asked me who died and made you professor, I have an actual name for them. Somebody died and made me professor. But anyway, the whole point of that was a lot of the material I'm showing you comes from this guy. So Robert Goodman was the name of the guy, and this is one of his charts, and he just wanted to show you that, you know, having a high performing team is pretty important. And so that's the parts of it. So what are we going to do? We're going to, what does good look like? Well, you know, there's some things you can read later, and this is kind of common sense, but I want to get a little bit further into it. I know I don't have a lot of time with you. So more of a successful team checklist is number of people. It says no more than 12 members on the particular team. Select members based on skills and potential. Make sure that we have adequate skills and they complement each other, and identify the skills gap. So when you're going through each of those tasks, you're thinking of what are the core competencies required in order for me to be successful at delivering this deliverable, this task. So it could be technical, problem solving, decision making. Also, personalities become important. So if you're thinking about somebody you want in your team, you're thinking of that criteria. They have to have some, maybe they have to have a professional engineering license. You know, maybe that's something's required for what you do. Maybe they have to have the right kind of programming skills are up to date. Maybe they have, so that's the kind of thing you're thinking about that team. And this is more of that same type of thing. So now get your team in shape, train them, prepare them for the change to come. So your project requires a certain level of training, even at above and beyond their training. That may be the history of where we're coming from, why we're doing this. It may be that they have the SQL language that they need in order to do the programming, but they never applied it in this way. So you may have to get them up to speed on what that business requirement is. And they may have to take classes on, or they may have to interview a lot of people just to understand, you know, whether what they know will actually fit into solving that solution. And then you've seen this 5 stages of project team development. Everybody seen that? Forming, storming, norming, performing, and adjourning. Have you heard that before? Thumbs up, thumbs up, thumbs up. Dylan, you seen that? Michael has. All right, this is just a tongue-in-cheek way to think about it. It actually works this way if you think about it. But when you get these people together, they start forming together and they start talking. And then there's personality clashes. There's natural leaders that clash with each other and want to do things their own way. So there's a little bit of a storming going on. And then you come in and it kind of, the storm, you know, there's an eye in the middle of the storm. And sometimes there's the storm passes and sometimes it's there for a little while. And sometimes these go around for a little while. And then once they get that settled, then there's performing happens pretty good. And then you get where you're performing really well, and then you go on to the next project and you have a whole different team, right? In the olden days of the movie industry, they used to have the same people that would go from one movie to another movie to another movie. Now, if you want to see a perfect example of world-class quality, you go to the movie industry and project management, because you can take on, I mean, outside of the Marvel universe, I guess, you have many of the same actors that go from Marvel, but a lot of times they'll come together and never have met each other. They'll work together. They'll go through forming, storming, norming, and performing and come out with the best and the world-class product, you know, a project of a movie. And that'd be a good example. I think that's Peter Drucker's example. So key lessons on teams. So members must shape a common purpose, agree on goals, define working approach, hold themselves accountable to results, and avoid temptation to make exceptions and excuses to all these things we agreed on. All right, so I'll let you read this a little bit back. So now motivating your teams is the next subject. So we have to establish the urgency, the schedule, those kind of things. We have to pay a particular attention to the first meetings. We want to get that forming, norming, storming out of the way as soon as possible, right? And we're trying to find a serious, worthwhile challenge that will motivate them. And we'll have to have the leader, which is you as a project manager, set the tone and the priorities. A lot of times when I go to meetings, we'll have a lot of democracy in it. You know, we'll go in because I am not the subject matter expert in anything. You know, I'm the subject matter experts in the tools, the project management, those kind of things. But if I get the best IT person there, I can't hold a candle to anything they do. If I get the best chemical engineer there, I've never been trained in chemical engineering. I don't know what they're doing. If I get the best industrial engineer, I might be able to talk and communicate and walk along that path. But once they get involved with something I'm not doing, they know it better than I do. So once they're in the team, I'm assuming that they're up on that subject for what they're doing better than I will be, because I'm working on different things, right? So I'm very much of a democratic. We vote for things. We take the consideration of the subject matter experts over everybody else. And if you're not qualified for that vote, you don't vote. But if you're the security experts on that project related to IT, I want the security people making that decision, and we want to support them. We may challenge them. We may say, are you sure it doesn't sound right? It doesn't sound logical, and make them prove to us, you know, but they make that decision and I back them up. Where I get involved is if there's a tie or if there's something that they don't want to make a decision about. And then I'll find either other people that can help me make that decision, or I will just, you know, I'll say, okay, that sounds most logical to me. We're going that route if there's an argument. Key lessons. Let's see, meaningful goals, best performance fosters, let's see, nothing new here. All right, let's see, key to individual performance. Let's see, I'm trying to hurry up, Mia, so that we don't miss the lunch start. People, all right, so we want to drive individual performance, but we really want to do it in a team environment. So we're not really looking out for number one, we're looking out for the team's best interests. And sometimes we can get people who are just lazy. And if you've ever been on a project with a group of people, you know that sometimes a couple people cover it and a couple people don't cover it as well. That's your school projects, right? If you've ever been on one of those, you know that there's not always equal. However, if you get the right people together, you can really do a lot, and you can really make a big, long, you know, you can do well. All right, so let's see, I think we've gone to that. So leadership means influencing people, getting people to do what you need them to do. That's what you're really trying to do. And I think we said this a couple of times, but the immature project manager has a bunch of people in your organization doing this, and that project manager is doing a lot of work. So we want to make sure, if you see my pictures of my thumbs twiddling, that's what I'm showing. So one of, this is from Dale Carnegie, but a friend of mine used to say this also. People try to do things to create good news about themselves, right? So the deepest urge in human nature is the desire to be important, the desire to do something interesting, the desire to create good news about yourself. And that's a motivational thing. Not everybody, another person said, what motivates people is what motivates people. So everybody's different. So the desire to be important or desire to do important things, the self-actualization, as Maslow would say, is important to lots of people. So now let's get into managing the team a little bit more. We got 2 minutes to get this started. If we look at McCahey, she says it this way, and that's found in your book, you know, under the highlighted sections in 264. And so now we're actually looking at managing people. And so now I'm going to give you more than what you expect related to the history of motivational theories, because this is important. You're dealing with people. This is how you're going to get the work done. And most of you have heard of Maslow's hierarchy of human needs. So we'll start there. And after we go through that, we'll go on to lunch. So there's the basic human needs. You have agreeable workforce, working conditions and level. And then the next thing is you have job security, stable work conditions, and good benefit packages. And then this is, the levels of motivation, Maslow's hierarchy of human needs. And we're trying to talk project management. So all this is based on the working conditions, salaries, and benefits. And, a caveman will go out of their cave and kill something, take risks to kill something to meet some of their personal needs, right? But once they have all they need, they won't take as many risks. And then social affiliation, I want other cavemen around me, that kind of thing. Esteem, to gain recognition, esteem from others. You want people to work on that together. And then you want to completely express yourself, and that's how it fits. So this is all needs based on nature of your work's content and that kind of thing. So first thing, the Maslow said that you get this one, the bottom one, then you move up, then you move up, then you move up. And his first research said that you did this before you did that, and you did the next one before you did the next one, you did the next one before you did the next one, and you don't necessarily jump. Later on, he said, well, if you're not meeting this, you may go up here and meet more of the social affiliation. So in other words, you can jump around a little bit more in his later writings. Let's stop there. Let's go eat lunch, and we'll come back here and we'll compare Maslow to 5 other different people and see what they say. But this is a good place to stop right now. See you at 12:30 your time, 11:30 my time. Anybody, if you want to stick around, ask a question, you're welcome to. All right, I'll meet you back here. Response might have been a little bit different. All right, anybody there? All right, Rob, I see you. See
I'm
some
here, Mr.
thumbs up.
Stevens.
Dylan, I hear you.
Yeah.
All right, let's just go forward. It is 1 minute after. Let's see, Michael's here. Tim, you there? Tim, Eric, Blake, Roy, Alex. We'll give it 1 more minute. Or we'll wait till the clock turns over to 32. This is good stuff. The motivational theories and how they all fit together is always really good stuff. Has anybody is Maslow new to anybody that's here now? Dylan, this is probably old to you, right?
Yeah, I had to study a lot of this for the PMP. I have to say though, when I took it, there wasn't a single question relating to any of these.
Motivational theories.
Yeah.
Well, that's good to know. I'm going to give you, and when I'm going through this, I give you a lot more than on the PMP or the PMBOK. So when you study your book, then you'll get an idea of, the amount that's covered is about right, probably.
Which of the theories do you think is most accurate according to your experience?
I think one of the most important ones is the theories on expectations, because that's the one I've found over and over to be more true than, Maslow. You kind of feel like that makes sense. It's logical. It's kind of in a bureaucratic organization that has, I can see that a lot, but, it doesn't explain artists and entrepreneurs and those kind of things, because they take a lot of risks to be self-actualized,
Yeah, like you said, I see expectancy theory throughout all kinds of literature, even 7 habits of highly effective people, all kinds of stuff like that.
Yep. So let's go ahead and get started. Thanks, Dylan. All right. So Maslow is 69. Maslow, that's when he was writing his stuff. It's a psychological review. I'm sorry. I'm talking about Clayton Alderford now. So Clayton Alderford is, we're going to get to we talked about Maslow. So it's kind of a variation of that. It's ERG theory, existence, relatedness, and growth. It kind of looks like the other one. So this refers to the concern with basic material existence requirements. This refers to the interpersonal relationships, and growth is kind of like the Maslow hierarchy. So this looks like, and below it is the kind of how it lays out. Looks a lot like Maslow. The difference is, there's a couple of differences, and that's where the starving artist comes in. The starving artist is working on the higher level needs before the lower level needs, or trying to get the higher level needs pay for the lower level needs, that kind of thing. Let's see, and it says that people can often work on one level before they get to or a higher level before they get to a lower level. And it's just a little variation of Maslow. All right, so let's see. Managers must recognize employees have multiple needs. So you're going to think about, not only do they have to be secure in your project, they have to have their charge numbers and everything in place, and they have to feel like they're safe and secure, where you're not going to get rid of them for little mistakes and things like that. You're also help them to reach their higher level needs. Some programmers, if they get in there and they can do something really interesting that they want to do, and then it just motivates them a little bit more. Growth opportunities. So in this case, the growth opportunities, if they're not there, they may regress to the lower level needs and do more socializing, that kind of thing. McClellan is So it's similar to this whole area of the Maslow needs, and I'm going to show you a picture of how that all fits together. But that's about 87, so it's close to where we are, right? So there's achievers and affiliates. The achievers, let's see, so if we think about this, the achievers are more interested in the success, and so they like the opportunity, so it motivates them. So think about everybody get an opportunity. For some people want more of the team environment and the social environment. So achievers, they expect to do well, and they expect to achieve and those kind of things. And then the affiliators, they're not challenged by the achievement of results as much as they might be for the friends and just being around the experts in the area and those kind of things, just that whole affiliation. Let's see, then Frederick Hirschberg, there's motivators and hygiene factors. I had this on a test one time, I screwed it up. But the motivators and hygiene factors, one's a motivator and the other is a dissatisfier. So the hygiene factors are more dissatisfiers. If you don't get it, you're not happy, you're not dissatisfied, but you're motivated by different things. So the hygiene factors might be working conditions and company policy and relationship with supervisor and those kind of things, and pay. And so Hirschberg said the myth of this being motivational, fringe benefits, human relations training, sensitivity training, communication, two-way communication, job participation, employee counseling, that kind of stuff is just not motivational. The other motivational factors are more intrinsic and lead to the job satisfaction. So that's recognition, achievement, possibility of growth, advancement, new challenges, responsibility, and the job itself are more motivational to this group. So they also has a kick in the pants. There's negative physical, and there's negative psychological kick in the pants, and there's positive kick in the pants theory. So if you compare all those together, Maslow's here. And as you go over, you see Alderford, and you see Hirschberg, and you see McClellan. So they all have similar motivators up at the top. And then if you looked at this is less of a motivator at the bottom. This is, you want to be there. And, you got to have these, but it's not necessarily motivates you to do your best work. So that's kind of a comparison of those four. Does that make sense? We went over it pretty quickly, but I don't think we need to spend a lot of time on it. And you have the slides, you can go back and read it a little bit more. All right, so now I'm going to look at 4 different methods or 4 different tools. And this is really leadership tools. So I'm adding leadership to the people side, although it's not necessarily something you'll be tested on. It's just something that this is kind of a graduate level understanding. So if you took an MBA course or a management of engineering course or something like that and dealt with people, then this is the kind of thing you deal with, right? So there's a whole bunch of people, right, over the years. And so what we're focusing on mainly is this whole behavioral part. How do we get people to achieve on our project the way we want them to achieve? That's our goal, right? So over here would be Taylor, and it would be related to, scientific management, size of the shovel, size, that kind of stuff. Weber be bureaucracy, and we're going to talk about a little bit of these, but we're really going to focus more on that group. So, so if we think about this one, there's 3 elements. There's activities, there's sentiments and interactions, and they all kind of relate on each other. So activities will create condition with the attitude, and attitude creates condition with your interactions. Interactions create, it's all related. As a group become more alike, they develop norms. So their attitudes, their sentiments, and their interactions become closer together. We're going to look at that in more detail because that's something you'll have to guard against in a lot of projects. So there could be, as they become more like each other, they may have harsh criticism of each other. They may use that to control the group. It could be positive, could be, oh, that's great. So if you've been in any kind of sports team, there's some that there's a couple of people in there just kind of are negative and create a negative chemistry sometimes. And some people, if you got a good coach and everything, everybody's helping each other and teaching each other. And so it could be positive too. So this is where this fits. We're going to look at the Hawthorne experiments. In the Hawthorne experiments, just one particular thing came out of Hawthorne experiment is what I like to look at. Usually when we get to this, I try to get this before the break so we can hold the Mayo, but we're going to go ahead and jump in and get to the Mayo right now. So this is another psychological approach. The Hawthorne experiments where they found that if you pay attention to people, that their productivity most likely go up. The example of that was a lighting study where they changed lighting a little bit brighter. And every time they did that, the productivity went up. Well, then they went back and changed it down a little bit lower. Every time they did that, the productivity went up. So the whole thing was psychological. It was that the more you pay attention to people, the more things change. And so it's a little different from the earlier methods in that this is psychological. How's a person work? So let's see, we're going to go. So this is what I like. This is one thing I really like. This is a group, talks about group cohesiveness and the norms, which is quality, right? So if you and I, any one of us, were thrown into a situation, chances are that we would have high norms, but we may say first jump into a group. You don't have a high group cohesiveness because you don't know anybody, right? But if you and I, either one of us, were thrown into this project, chances are we'd try as hard as we could because you're in a master's program, right? Which means you're probably motivated to work hard and you're motivated to give a little bit more, right? So, so we're going to have some positive results. If it was the bottom part, low norms and low group cohesiveness, if you throw somebody in that category over here, then they're not going to work hard. They have low norms. They're not pushing themselves too hard and they don't know anybody. So they're going to have flat line, right? There's just not going to be a whole lot of input they're going to give. If, however, you have really great team building, really high norms, so you're going to get a high positive impact, right? So over here, you have really low norms, but high group cohesiveness. That's like gang warfare. You have a gang coming in and they're going to have negative impact, but they're going to do it really well as a team. All right. So now you sit in a situation, you inherit somebody's team, right? So if you find yourself over here, what do? This is a conversation. Flat line. Got a bunch of people, low norms, no group cohesiveness. What do? Team building? Who says team building?
You fire someone.
Okay, that's something you might be able to do. But now you have flatline, which means they don't really know what they're doing, right? So who says team building? But fire somebody is often the right answer. So I hear team building. So what you just did is team building. You took these very low norm people and you put them in this category. Now they're a good team with low norms. Does that make sense? That's the worst case over here. But see, that's the kind of that's what's important about this. There's a time and place for everything, right? So here we're going to keep them broken up. We're going to get their norms up. We're going to try to bring them into this box. Okay. So we're trying to move this direction. And now, who said fire somebody? All right, Blake, you're exactly right. If you're over in the negative here, you have high group cohesiveness and you have low norms, get rid of the troublemakers. You see two little kindergarten kids, they're causing lots of problems in your class. What does the teacher do? Put them in different classes, put them in different sides of the room. They split them up. That's what you have to do here. You have to split them up. You have to get rid of that leadership in this team because there's informal and formal leadership, right? So first thing you do is split them up. What do you do over here? You keep them split up, but you start training them. Now you're over here. What do you do over here? Mia, I know you know the answer to this. You got a whole bunch of good people. They're just not cohesive.
You put them back together as a team.
Get them around a common objective and goal and give them some standard work to get there.
Yep. So we're assuming that they know what to do at this point. They know what the goals are and everything else. They're just not cohesive. So now we're trying to build cohesiveness. We're moving them over here.
I need something emotionally impactful that'll pull them together.
Yep. It could be that. It could be all kinds of things. So anything related to team building is what you're trying to do at this point. So each one of these boxes has a different tactic. So what do you do? It's kind of situational. It depends. Well, maybe half the group's over here and half of them are up here. Well, if that's the case, you approach them differently. You don't tear the ones that are doing well apart. And then, so you got to be careful. Not everybody gets the same treatment. And it's like your kids. Some kids are just working really hard. And other, you may have a child that doesn't work hard, or maybe is in a bad group. You don't want to treat that good kid as if he was a bad kid. And you want to treat that bad kid, when I say bad, I mean bad behavior, as if he's doing everything right or she's doing everything right. So you got to think about that. You don't have to be mean. You're not talking about mean. You want everybody to look good, but you might have more of a mentoring going on with some individuals that you can see some things that in their character that makes them who you want to keep around. And some people, you just got to get them out of the situation. You got to get rid of them. So here we divide and conquer. Here we train. Here, well, that's not right. Yeah, here we train. Here's team. For some reason, I read that here. My dyslexia is acting up. So I read train as team building. So here we divide and conquer. That's the hardest place to be. Here we're training, but we're keeping them separated, right? So they'll learn, because you get a team of people together that are in this category, and you try to train them. You're not going to get any results, right? Because you're going to have a few people that will work against your training. I once went into Johnson City, and I was training a group on how to weatherize homes, right? And there's one guy in there that knew everything, and he was giving me a hard time the moment I walked through that door. And I looked younger than him. I looked like I didn't have much experience in him. I was dressed nice. He came in work clothes, and he just figured he put me in a box, right? And so the first thing I had to do is I had to take him out in the hall, and I had to have a conversation with him. So within the first 10 minutes, I took him out in the hall, and I said, listen, you're killing me in there. He was really smart out. He said, am I really killing you in there, Craig? Is this hurting your feelings? Things like that. And I said, listen, I'm here to train you. You have to have this training. You have to have my signature on your certification to go your next step. What if I go and tell your boss that you're not participating and everything else? You know what's going to happen? You might get fired over it, but you're not going to get the certification. So you go back in there and you help me in this class, and I'll make you look good. You go back in there and say one more negative thing about me, and then what I'm going to do is I'm going to kick you out of class. And so after that, we spent a week together. At the end of that week, he was my best friend, because every chance I got, I made him look really good. And I said, okay, what would you say about this? You have a lot more experience than me in this because you're out in the field every day. What would you do? What did I say that was right? What did I say that was wrong? And I gave him a chance to talk. And he was he was my best friend at the end of that class. And it was important. I needed him because he was giving all the tours, and we were doing all the house, looking through all the houses, and he was in charge of all that. So if I did anything else, it would have been a disaster. I would have failed. But not only that, but every single person in that class, there were like 20, 30 people in that class, they came up to me at different times and said, man, I'm glad you did that, because he is hard. He is a bully. And so, but that was just it. You got to divide and conquer. Have you guys ever witnessed that in real life in your work day, where you had somebody either as part of your team that no matter what happened, they didn't want to participate and they didn't want you to participate? That's kind of what we're talking about. As a leader, you're the leader of this group and you got to make it happen. When you get to this part, you're just feeding them and nurturing them. You're just trying to keep everything smooth, avoid, trying to minimize the conflict as it comes up, because there'll always be conflict. And so this is the curve you take. That to me is worth everything. That one slide, knowing that about a group and thinking that way is about, so much. So now let's talk about conflict. Here is, these are my degree of cooperation with you. Say you're the boss, and this is my degree of assertiveness, satisfying my personal goals. And say I'm the boss, then what we'll do is, where's the best place to be? Do we want a high degree of cooperativeness as a 9-9 and a high degree of assertiveness, which is you're going to do it my way, but I'm going to cooperate with you. That's what it says. So 9-9 is it. So let's see. What about this? When is forcing the right thing to do? I tell you that my degree of cooperating is low. My degree of assertiveness is high. When is this the best thing to do? And we'll say, which one's the best? It's back to situational, right? It depends. So when is forcing my will on the team the right thing to do?
When you're establishing what the objective or desired outcome is.
Yep. So if people are fighting that, then I have to assert myself. This would be example, if they're going to break the law, break regulations, get us fired, I better be really tough, right? All right. So now over here, this is withdrawing. I'm not going to assert myself. I'm not going to cooperate. I'm just going to withdraw. When is that the best thing to do?
Sometimes when you're teaching.
I think there might be a better answer. But withdrawing would be, I'm not going to assert myself. I'm not going to be assertive. I'm not going to be tough. I'm not going to cooperate. So let me give you this situation. What if it's a no-win situation? You think about your wife or your husband, and you could say, there are times when this isn't worth the fight. It's a small deal. It's not worth the fight. There's no win going to come out of this. We agree to disagree. One of you is the Republican, one of you is the Democrat, right? So it's just like, if we want to keep this relationship, we withdraw from these subjects. So if it's a very, very small deal, if it's not on the critical path, somebody has a different opinion, then, I'll withdraw from that, and I want to assert myself, and I won't necessarily cooperate with it because I disagree with it, but I'll let it go forward, that kind of thing. And there may be other ways to look at me, but that's what I was thinking. All right. So what about up here? Accommodating. I'm going to give you everything you want. I'm going to just not assert myself at all. I'm going to be as cooperative as I can. When is that the right thing to do? When you're wrong, when you find out you're wrong, when somebody's trying to keep you out of jail, because if you'd done it that way, you'd get fired or something else, and you figure that out. So a lot of times I just say, I'm not going to assert myself. You're the subject matter expert in this. I'm going to go with what you say, and I'm going to do everything I can to make that happen. So that's kind of an example. I'm going to be accommodating. Sometimes it's the right thing to do. If you did it all the time, if you did any one of these things all the time, you'd either be a jerk or you'd be a pushover here, or you'd be, unavailable, I guess. So here's where we're trying to get to: collaborating, where we're asserting ourselves and we're cooperating and we're listening and we're trying to work together on things, right? And each of these is one. So this in the middle is kind of compromising. I'm going to give a little, you're going to give a little. Sometimes that's the best place to be. And to give you an idea, negotiation, if you ever bought a car from somebody selling this car, then, you might you both feel a little better if you negotiate a little bit. And that would be like, all right, I want to, this car is worth $10,000 in my mind, but I'm not going to offer $10,000 for it. And in your mind, it's worth, you got to have at least 8,000 for it. So if you go in and say, I want 11,000, I might say 8, and you might say, well, 8, you're getting closer. And I already met my amount, right? But how about, you won't go 11, how about 10? And I say 10, I can see where he came up with that, but I just feel like that's very, that's maybe, and I'm already willing to pay 10. The other person's already willing to pay 8. So we might say, well, how about 9? Well, now the person's willing to get 8 for it. They feel like they got $1,000 more than they want. I'm willing to pay 10 for it, and I got $1,000 more or less than I was going to pay for it. That's my top. And so by doing that, we both walk away thinking we did a great deal. And so compromise works kind of like that. It improves the motivation, it improves satisfaction if you don't take the highest number. And I learned this the hard way a couple of times. One is I had this old Transit in a wooden box. It was my father's Transit, but I don't really, my father died when I was 13, but I had a farm in Sunbright, Tennessee, right? 186 acres, bought it for nothing, but I didn't have a lot of money. And someone came in and redid all of my plumbing, because the plumbing was leaking in certain places. And he saw that and he says, I like that. I'll take that. And my ex-wife at the time said, well, he might trade it, for the work. And he says, great, I'll trade it. So he came in and he said, I'll trade you all the work I did for this Transit. And I said, sure. Well, he immediately thought he got a bad deal, right? And this was a neighbor and everything else. So he immediately rethought that because I didn't play with him a little bit. And I didn't play with that Transit, and so you got to compromise a little bit and just, psychologically. So this is I win, you lose. But if we do it right, it's a win-win because we're staying out of jail, baby. This is I lose, you lose. But if we do it right, we avoided an argument, right? So we're not even worried about it. This is I lose, you win. But if we do it right, it's a win-win. Because that means that you kept me out of trouble. I was wrong. I should avoid my ego and tell you when I'm wrong. And you may have to convince me I'm wrong, but once you do, I should accept that, each one, I keep thinking of politics right now. So, forcing, withdrawing, accommodating, collaborating, all this kind of stuff, win-win. We do it with everything we do, right? Compromising, I give a little, you give a little, we're both happy, but we're not as good as where we could be. This is two minds come together, create a third mind. This is the synergy part. But, if we were looking at it, we'd probably want to go in this order, if we had to, because we want to be in the right, but this is kind of what we would do. Last thing we want to do is withdraw and leave something undone that needs to be done, but it's all situational. And you guys probably seen this before. This is the internet, and you probably may have already seen the picture. It says, dear darling husband, before you return home from business trip, I had this pickup problem and I accidentally damaged the car and I hurt your truck and I hurt the garage door and everything else. And here's, please forgive me. And then here's the picture. And then PS says, your girlfriend called and left a message for you. So I always thought it was funny. So conflict will exist. Conflict, and this is an old joke from the internet, but conflict is always going to be there. Here's kind of, if we go back to the change curves and the pattern of stress and all that kind of stuff, then we have something that creates a conflict, and then we have some kind of curve. There's a fight, flight, and facing reality as part of even little conflicts, right? And it may be minor curves compared to that. This is a shock of the problem. This is we getting angry. This is, getting over a little bit. Now we've, just it deteriorates, and over time it gets better, right? So conflict kind of happens like that. The traditional view is conflict is always bad. More realistic view is conflict is inevitable. It's natural. We got to manage it. We can't get rid of it. So conflict, if we think of it psychologically, conflict means people care about it, and it's a process to be managed. It will never eliminate conflict. So characteristics of conflict is conflict shows people you care. Conflict is always going to happen somewhere. Conflict can be productive or destructive. Conflict is, all these things that we're talking about, really conflict that we've heard about before. Conflict to help build relationships. And I think about that in high school or in elementary school, two boys would get in a fight. I remember times that we had little altercations in the past that may not work like this anymore, but in the past, two guys would fight in a schoolyard and they would become best friends. And it doesn't have to result in a loser. You can have winners in conflict too. So here's what naturally happens in a team. You have this little conflict going on, right? So this is a team building for maybe in the park. So it happens a lot of different places, but let's say it's during team building. So we're starting a storm right here. And then there's beneficial conflict. We'd keep that conflict down. And like we were, I think Mia, you said this, but with that little bit of struggle, we come up with better ideas. And then there's a threshold that becomes destructive, right? And so that's where we get above that threshold. It becomes personal or political, and it just becomes destructive. And so what we're trying to do is we're trying to manage this conflict so it doesn't reach into the very destructive part. And so when we think about conflict, there's conflict with our customers. So if we had a retail store, we would maybe have a conflict with the customer, but that's one thing. But the worst conflict comes with the people who work on your team, because that carries with you for the life of the project, right? And so you got to face those quick and get over those quick, because every single thing you do affects every single task that those guys or ladies or whoever's involved in, right? So co-workers is probably the worst possible situation. It adds more stress, adds stress within your team, adds stress with everybody you interact with. So it could be a conflict over limited resources. Somebody needs that time in the lab and somebody else has it. And their goals are important too. Maybe the goals aren't the same. Maybe the roles aren't laid out well enough and people are getting each other's turfs. There's just different perspectives from it, and there's maybe just poor communication. Oftentimes, you especially see this, and I keep going back to the politics because we're going through election, right? So you see this all the time with either miscommunicating on purpose or spinning, or you said, so-and-so said it this way. Well, that's, if you listen to the tape, it's not what they said. Or if you put yourself in those shoes, they made a mistake. They didn't mean to say it that way. It's just a slip of the tongue. We all do it. It's not intentional or something else. And sometimes it really is intentional. But just the poor communication could be that, oh, I thought you meant 12 o'clock Central Time, and now it's 12 o'clock Eastern Time, and we're late, or whatever the case is. So communication is often a big deal. All right. So as you guys see something, then let me know if there's. All right. So we're all going to see things differently, and without feedback, we'll just never really know. So it spirals out of control often. So it kind of compounds on each other too. So let's pretend like this is an event E, and this is person A talking with person B, and person A and B are having a little conflict. So there's a conflict here. First time, no big deal. It's a minor conflict. The second time, it escalates up a little bit. So by the time you get the third or fourth time of miscommunication, pretty soon you're saying, well, you never listen to me, and you never hear me, and this, that, and the other, and people of different backgrounds have different views of different things, and you can't always communicate well. I mean, men and women are different. people, women from two different communities are different. Men from two different areas of the country are different. So all this together just creates little barriers between each other. I mean, a lot of times, this is kind of example of men and women. Men and women actually have a more complete brain than a man, because when they're in the womb, there's an acid that forms over the brain, and it separates the two hemisphere. I can't say it, but the two parts of the brain, left and right, right? And so it's good for some things like battle. That's exactly what you want. You don't want to have the emotion tied up with the action. But women are more connected. Their brain wasn't damaged in the birth canal. And so they have a little bit different view on things. And neither one of them are better or worse in every situation. There's exceptions to everything, but just that two differences makes you see things differently, and then if you add to it areas where you grew up and how our parents treated us and everything else, there's going to be conflict anyway. So that's it. So this all happens. We have to manage that. All right, so let's see. And here's Dale Carnegie. The only way to get the best of an argument is to avoid it. All right, so that sounds good, but let me tell you an example of a 600-pound gorilla in the room. This is observation I made. There was a company, there was a fairly new company, and the president of the company was having an affair with the vice president's wife. Okay, 600-pound gorilla in the room. People in the company knew it except for the vice president. You're going to have conflict. You're going to destroy a company over that. There's all kinds of things. There are 600-pound gorillas in your room. There are 600-pound gorillas in your team that you may or may not know about. And the worst thing you can do is keep it in the dark. Because if it's kept in the dark, imagine you're in a dark room with a 600-pound gorilla. Right? That's what you're facing. You have to shine a light on it so you can avoid it. Shine a light on it so you get out of the room. Shine a light on it so you can see it. To cover over conflict is not always the best idea. You don't have to share it with everybody. You don't have to spread gossip, but you do have to go to the people involved. And you do have to talk to them. You have to bring them in. You may have to bring in HR or somebody else. So managers are doing two things. They're managing the conflict. They're actually stimulating the conflict, because we want some conflict, because we want 2, 3 or 4 programmers to get together and argue about the best way of doing something, or, to a certain degree, but we also want to resolve it and come up with a solution at the end of that. All right, let's see. So overcoming all this. So following strategies will help to overcome some of this. So don't just jump to a conclusion, based on what your own mental models are telling you. Remember, we showed the mental model exercises about thinking in the box. Don't just jump to a conclusion. Think about it. Get it out. Don't just say, well, those people are always like this. That's just what those people are. They're all, this, that, or the other, because everybody's different. You may find that the person's least like you is most like you. You may find that the people who are the most different from your background may have been brought up just like you and think just like you and everything else. So it's just don't run with what your first thoughts are. Make sure that people don't feel attacked. You're not there attacking them. You're just there trying to solve the problem, right? Avoid generalization, irrational fears. Respect each individual's perspective. The more perspectives you have, the stronger you'll be. I look at, all the differences in the United States, and it's kind of like a meal. It's all kinds of flavoring. It's all kinds of unique ideas, all kinds of unique cultural things, all kinds of different perspectives. And some people are like, hot peppers, and some people are like a little bit of salt, and some people are. And so if you mix it all together, you have a real flavorful mix of meal, and it makes life more fun. I mean, it'd be really boring if we were all exactly alike. All right, let's see. It's not clicking forward. There it is. All right, so also we're trying to focus on the situation, issue, and behavior, not the person. Maintain self-confidence and self-esteem of others. Let them save face. We all say stupid things. We all do stupid things. I can tell you stories. I grew up, and I'm 61 years old. So I grew up when people talked differently, and then people had a different turn of phrases. If I use some of those same turn of phrases, even in innocent ways, they come across in bad ways, right? Because it's just crazy. That you don't want to find ways that people you can divide yourself from other people. You want to find, look over their mistakes and help them look over your mistakes. Be open, be clear, maintain constructive relationships, take initiative, make things better. You're not there to meet somebody halfway. You're there to meet somebody 80% of the way, 90% of the way, 100% of the way. And then maybe they can do the same. Maybe you can look at each other point of view. Sometimes when I talk in project teams, I'll reiterate what someone says. I'll say, here's what I think I heard you say. I think you heard you say that this will take a little bit longer because we've had a major problem in the supply chain. The supply chain has been fixed, but it still has a machine time to get this work done. So no matter what, it's going to take 9 months to have that baby, whatever the situation is. And so you just have to reiterate what you're trying to, what someone's trying to say, trying to communicate. My thought is, if you can communicate it better than the person, or, try to communicate as well or better than the person who is trying to make that point before you go to the next point, it's like, let me see if I understand you, and you tell me if I'm right. And then I'll tell you what I'm thinking, or you try to explain what I'm thinking, and we'll just keep going until we get this down, and because you're trying to build that relationship. Lead by example. All right, so now you're in this situation and it's very impersonal, right? It's related to some kind of technical issue, and we're trying to solve this. That is great. We're both seeing something from a different point of view. Let's keep each other in the together. And so now we say, well, yeah, but you smell bad too. Now we just moved it out of the technical and we're talking something personal, right? Semi-personal in this case. And it could be, well, I don't like, I'm going to tell your boss that this is the way we're supposed to do it. And that becomes a semi-personal. And then up here is like, and your mother smells bad too. It becomes very personal. It's totally outside of the technical work. We just insulted somebody's mother. So now we're up to this level. Which one do you think will get shot over? In a world like we live in today, which one do you think will get shot over? Because that's what we're dealing with. We go out in the world and we say, okay, I got to get across this street and there's a car blocking me, and I just, it's technical, and then now I'm gonna say, I would call the police on you. And then now it becomes more of a political issue, conflict issue. And this is me going ramming my car in that person's car. Which one are you going to get shot over? This is where the, life and death comes in play. And so what you want to do is you want to keep knocking it down a level. If you're up here, push it down to this level, get someone else involved, take it out of your personal interaction and call the police, or your personal interaction, call their boss, set aside. Once it's this level, then get it back down to the technical level and eat a lot of crow, just say, yeah, I'm sorry. It was uncalled for. I disagree with you. You disagree with me. That's where we are. But, we have to do it. We have to do it that way. All right. Mia, did you like that? I saw that laughing face I made you. Was it the mother insults that I did or what?
Yes, the mama joke.
In some cases that's banner. And if you're good friends or if you're, you kind of have your own rules of how you play. Right. And so sometimes, I had friends, I had this Marine Corps master sergeant and he was all testosterone. And he was one of my best friends, right? We'd be walking down the street and he'd push me into things. I would be walking down the street, looking down and push me over in a pole because he wanted me to pay attention or something. And that was the way we played. And he'd call me names and I'd call him names. And he says, Craig, you're the only one in my life has ever given me as hard a time as I gave them. And he liked that. That was where he was. But, I also saw, I was sitting at a pool at YMCA one time and I saw this young kids, teenagers come in and there's a boy and his girlfriend. They were loving each other and everything else. They got in the pool and the girl starts flashing them. And so the boy in his mind, he's saying, oh boy, we're going to play rough. He likes playing rough. He goes out and wrestles with his friends and punches them in the shoulder and all kinds of things. So he starts splashing her back. Well, she gets a little more courage and she splashes him. She was much smaller than him. He's a bigger guy. And so now he gets rougher, thinking that's what she wants to do. She wants to play rough. She wants to wrestle around, do things. And then I saw fear go over her face because she misunderstood what he was doing and he misunderstood what she wanted. And that's how things escalate a little bit because they're in a pool, she was she just wasn't expecting his testosterone to kick in like it did. So you never really know. You got to feel people out what they like. I've worked with people that always wanted to practical joke and I worked at people that would never practical joke and it just wasn't part of what they wanted to do. All right, so now this one is more of a management grid. So over here, this very high concern of performance, and this is a high concern for people. So this people versus performance. We're going to go through this a little bit. I think I'm looking at my timing. So I'm going to pass through this. I'm going to go straight to situational leadership, but you can read this. It's very similar to situational leadership, but in this, we'll talk about theory X and theory Y. So theory X is that people want to get out of work. They dislike work. They avoid work, that kind of thing. And then that would be down in this task manager. So team leaders where you want to be, see the same numbering system, high performance, and this is high people skills, that kind of thing. So I'm gonna let you look at this part, but we're going straight to situational leadership. That's why up here is why this is everybody wants to do really hard work. They're really good at it. So that's a why. Over here is, I give little, it's kind of low concern for people and low concern for performance. And sometimes that's a very bureaucratic way of looking at it. All right, so let's see. Next one, this is one I want you to pay attention to. It's very similar to this one. If we had more time, we'd talk about all kinds of stuff, but we're over here. We're looking at situational, looks very the same. This is me providing guidance. That's my task performance. This is positive supportive behavior. That's my relationship performance. And these are my situational leadership. So situational leadership goes back to it depends. What's the best leadership possibility you can have for a situation depends on the situation. And so if we go over here, we're looking at, this is, well, go back one. Well, it says here, this is your leadership style. As a project manager, you have above average amounts of task behavior and below average amounts of relationship behavior. Think of a drill sergeant. When the new when new people come into boot camp, they're over here. They're very in your face, task behavior. That'd be an extreme, right? So this is the readiness of that person coming into your team, right? And this is your behavior. You're going to give them a little more effort in explaining the task and a little less effort in building that relationship. And then, so their readiness, they're unable and unwilling or insecure. They're coming into your team. They're unable, they're unwilling and insecure. Now, Rob, why did you hire that person? Why did you bring that person to your team? They're unable, unwilling, insecure.
Yeah.
Because they had potential, or they had some characteristics that you thought you could build up.
Yep, and that's why you pick a person. But everybody you bring in your team is going to be unable to do what you want them to do till they know it, right? They're going to be insecure about how they're going to fill it out with how this team, and unwilling just means that I'm so insecure, I don't want to make a mistake. So they're kind of unwilling to step out on their own. It's not a negative, it's just a fact of life. So here, this is above average amounts of tasks, still above average, but the relationship, we're starting to build that. They're unable still, but they're willing. They understand what the situation is, and they may have too much confidence, right? And so over here, you're going to have above average amount of task behavior, or lower amount of task behavior, but still above. So now they've been in your team for a little while and they fit in this category. Your style changes. They're able to do the work, but now they're unwilling and insecure again. Isn't that strange? They're over here, they're confident and secure, but they're overconfident. So when I grew up at Holiday Inns, we had front desk people. Well, they didn't know what to do, anything else. We brought them in, we had to teach them stuff. We didn't concentrate on a relationship. We try to be nice, but we weren't building a relationship. We're building, this is what you got to do. This is what you got to do to keep this job. And then over here, they were still, didn't really know that much, but they thought they did. Yeah, you told me that 100 times, whatever. And so here, to get over here, they may have seen something, made a big mistake. I think I hold the reservation mistake, the longest reservation mistake. So someone wanted to go to someplace in Georgia, and I put them in Innsbruck, Austria. So, just by putting the wrong code on the holodeck system at the Holiday Inn back when it was a holodeck. And so I think I hold that record. I put someone that wanted to go to Statesboro, Georgia into Innsbruck, Austria, Holiday Inn, hotel room. And I fixed it, but that's a big mistake. But another thing they might have seen a robbery. Somebody might come in and robbed them. So now they're able to do all the work. They've learned a lot, but they're unwilling, insecure. They made that big mistake. Somebody complained, whatever. And so now you got to treat them more behavior. They already know what they're doing, so you can back off a little bit. And down here, they got it down. They have confidence, they're willing, they know what to do. And now you can back off that relationship. You don't have to spend much time with them because they already know what to do. And that works pretty good. This is kind of every place you ever go teach management, you'll learn this model. All right, so now this is what it is. Here we're directing, we're coaching, we're supporting, and we're delegating. We can't delegate until we get over here, right? All right, so now I had the same thought. So my wife is a music lawyer, and she said, I hate that. I don't like that. He says, why? Because I want to have a higher relationship with my peers and my bosses. So professionals are different. So if you have a master's degree, you expect this. Whereas if you're working in a factory somewhere, this is a natural curve. So this is more, if you have knowledge workers, and this is more what you live in probably, then even that relationship here is they go out and get a beer together, they go golfing, they do things together. So even that, can change a little bit too. All right. So let's see. What time we got? We only got 6 more minutes. All right. So I will probably skip over a whole lot of stuff from here. Let's see. I think your book covers a lot of good stuff. So I'm going to see if I can get through this. There are a bunch of different sources in empowerment. And so let's go straight to this. The law of empowerment. Only secure leaders give power to others. So you're trying to empower people to make decisions when you're not there, right? And let's see. I have 5 minutes till 12:30 and we got to end at 12:30. So I think maybe the best thing to do is let you guys go take your break so that I don't interfere with your next class. And then you have all these slides. I put all these in webinars and different things, so I can send you a link to me explaining all this stuff if you're really interested. But I think we covered the main stuff I wanted to cover, in your book kind of sheds light on some other stuff. But I think you got a good feel for the motivational theory stuff. Is there any questions, or you think that's a good plan? A good plan? All right. And I'll try to send you links to, me explaining this. And if you decide you wanted to go and see this, this is by far the best stuff I was going to show you because I invented this stuff. But so I'm going to market it a little bit like, yeah, you got to see this if you want to see it, but it's not important to a class. All right. So that's it. I'll see you guys next week. Next week, we'll talk about communication. And if I can add any of this stuff to the communication and it makes sense to do that, then I'll do that. But I appreciate you guys showing up and having such great questions. Call me if you want to. That's the best way for me to solve a problem. I try to look at the emails, but I get 100 a day, so try to call me directly, and I can't avoid that, right? And Omkar, just let me know when you want to get together. Send me a link and we'll talk about fixing everything.
Yes, sure, Professor.
Thank you, sir.
Thank you.
That's it. Guys, go take a quick break.
Figure everybody could use a little motivational music right now.
There you go, Blake.
Joe, are you stuck in a closet next to your HVAC? Okay, it's a big closet. You're on mute. Nobody can hear you.
It's kind of Josiah's playroom, but I've been using that chair right there as a recliner when I couldn't stand it no more.
You make him play next to industrial equipment?
Yeah, why?
Okay. Maybe he likes to work on the furnace. I don't know.
That's just a mock-up for him to start learning. That's not the actual furnace for their house. That's just, start teaching them young.
Figure that's the qual process that Royce would put him through if he had to go with him. Oh, you'd appreciate that, Ro. Are you done, by the way?
I'm done.
Good. Congrats.
You're ringing me through took me through the ringer on the lookups, which historically has never been the case, but my current boss has taken it to a level that has never been seen in the past, even by me.
Yeah. You was asking about the 15. It's really strange. A lot of the questions I was asking yesterday, Kirsten was telling me, no, you don't need to worry about that. You don't need to worry about that. Fire systems and some other stuff that I was like, wow. So I don't know.
To be careful now, because that's what burned a lot of us in 12. You
Well,
get one story from one STA and you go to another STA or another knowledgeable STA and they tell you something totally different, and you get to your mock board and you get blown away.
So, that's the trap they're fixing to fall into
That's
with those
why-
ship managers. So,
Yeah. That's why they've got to get a structure to the training program for shift manager STAs.
yeah.
So it's a building block on each team.
Hello, how are you?
Hello. How are you, Enrique?
All good here, thank you.
Sir.
Hope everything is good with everybody.
Yes, sir.
Did you have the class finish a while ago, or you still need a break?
We just broke loose from it just a few minutes ago. I think some still away.
Yeah, I can see that. All right, let's wait the usual 1:35 and then we'll start. All right. So everybody ready? Good, good. All right. So for today, we're going to go through the concept of capacity planning and management. And I guess to this point, the two simulations that you've been working with should have provided the fundamentals of how to handle this. Now we're just going to put some structure to it in regards of the perspective from the CPIM certificate. So in that sense, what we're going to cover today is the definitions, some of the techniques. We're going to spend a little bit more time on the techniques, and then we're going to do the review how certain things are done nowadays, which is the simultaneous scheduling, and then capacity management. So the capacity planning and management basically goes through the concept of matching basically what we can do with what we want to do. And that goes, I mean, as we have progressed through the lectures, we have been into analyzing the MRP and the master production schedule and all this sort of thing. We take a step in parallel, trying to define for the entire design of what we want and we have to do. Where do we hit changes in capacity? Well, we know it's could be the design of the process, the design of the facility, but then minor adjustments can go around the number of resources, labor that we want to incorporate into the process, the availability of the machines, the availability of the materials. So into these capacity plans, basically the bigger fluctuations, as we have mentioned before, may happen into trying to pursue the master production schedule with the strategies we have defined before. But from the perspective of how do we match over the different ranges in time, what we can do and what, regardless of the strategy that was selected. So one trade-off that we can have when working with this is to enhance throughput with the reduction in capacity utilization. So all in all, this is something that may be resounding to what we covered with factory physics, and though we're gonna bring in again the topic of the theory of constraints. Yet this is more on the execution from the MPC system. How does it work? So the objective here is basically to know what we're gonna need early enough so that we can plan and prepare for it. Flawless execution of these will avoid any surprises. So yet again, if we look at the MPC system, manufacturing planning and control, we have through the lectures until now gone through the entire section of demand management, sales and operations planning, master production scheduling, and then we went through the MRP, right? We covered that already. And in parallel, capacity will have a specific connection with each one of these stages at every level. So in the long range, which is planning for a year or planning for maybe 5 years, whatnot, this goes more into the design of what we actually want to achieve with our facilities. Into the medium range, it goes more on the human resource standpoint, as for what is the fleet that we're going to need, how are we going to make the materials available, and what quantities and whatnot. And in the shorter range, this goes connected directly with whatever is happening in the shop floor and daily operation, which includes, well, the plan for today is this much, but these are the circumstances that we're facing today because somebody called in sick, because some of the material didn't come, because this machine is not working, whatever it is. So there are certain techniques that we're going to cover today. We're going to go through this one, rough cut capacity planning. That is, retroactively feeds on the master production schedule. We're going to use the capacity requirement planning as well, which it goes connected directly with the MRP. And then we're going to look at a couple other techniques, which are in the execution, as we said, the finite loading, and then the one that involves the daily supervisory and managerial decisions in the input-output analysis. All right. So how does it link to the modules? Well, the resource planning is directly connected to sales and operations. Again, this is the projection of what we want to achieve with the facility that we want. And it converts that data into aggregate resource units, right? Remember, in the long term, we are always going to be dealing with the aggregates. When we jump into the rough cut capacity planning, we're directly connected with the master production schedule. Although the master production schedule is going to connect to every single technique that we're going to use today, this is probably the closest link to that one. And do you remember there in the master production schedule, there's the freezing zone of things that we don't want to change, and it's the master production schedule is a little less flexible in order to make daily changes. So if we were to do an analysis of these techniques from the least flexible to the most flexible, this part would be the least. And the right-hand side, and I'm sorry, I'm trying to work out things with the screens here. Well, the right-hand side would be the most. I'm sorry, but I'm not able to move the screens for some reason. I guess when I'm doing the annotations, it won't allow to do that. So for most flexibility, it means that we have the technique to meet reaction times on, this could be the daily basis or hourly basis. And this, on the left-hand side, we're dealing more on the longer term. All right. So for this, we're going to go through some techniques that basically summarize all of these from the different approaches, from the least flexible to the most flexible. So we're going to use the capacity planning using overall factors, capacity builds, resource profiles, and then capacity requirements planning. For this, what I want you guys to do, there's an Excel file that is inside the tab of today's module. Please go ahead and bring that, open that file, download and open. All right. Fabiano or Armin, could you remove the co-host privilege and then give it back, please?
Yes, sir. Okay, you should have it back now.
All right. For some reason, my Zoom in the interface is not working with me. So I guess I need to leave the session for a couple minutes and come back.
Yes,
Please
sir.
pause the video.
Yes, sir.
All right, I'm back. Can you guys hear me? Yes?
I can hear you, Dr. Enrique.
All right, thanks. I'm not sure what happened, but let me go back to the slide set. All right. Okay, so I'm gonna go interchangeably within screens. So please, at every change I make, please confirm that you see what I am intending you to see. Right now, you should be seeing the PowerPoint. Are you looking at that? Great. So the first technique, the CPOF. It's a rough cut capacity planning approach. It's very, very, very simple. All right. As we mentioned, it connects directly to the master production schedule, but it uses a historical factor, all right, which is based on percentage of time that or percentage of utilization of that work center, all right, and production standards. So any requirements on labor or machine hour capacities are directly derived from these ratios. And basically, if these historicals are not quite accurate, then the whole thing becomes useless. So if you go to the Excel, you're gonna see on the first tab, CPOF. This is an example of a master production schedule for 2 parts, all right? So we have product A, product B as a finished product. And this goes over 13 periods. Let's call it days or weeks. Doesn't really matter much. Yes, days would work for the subsequent examples. And these are the planned requirements in the master production schedule, totals for each one of them. And then we assign the standard hours for direct labor. And these are numbers that we're gonna assign for each one of the products. So where do we get this information from? It could be from the same MRP system, ERP system, sorry. It could be a database of standard times. It could be something that you have constructed. At the end of the day, it's a standard that you have developed. I don't know if you remember that we explained in 527 how to calculate standard times. I can leave that for aside for a minute, but the important thing here is that when we're dealing with this number right here is the standard time for production. All right. And in this case, we're dealing with direct labor. Okay. One of the projects that we're working right now, they are actually using a predetermined standard time system, which is called MOST. I don't know if you ever heard about it. MOST is the acronym for Maintenance Operational Sequence Technique. And it's a very useful method if you know how to use it. The reason why they acquired this particular method is because their product range changes so much. They probably have in catalog right now, I don't know, more than 2,000 or 3,000 different products. So that developing standard times through observation, through time studies, it could be very tolling and very slow. So the designers, this is furniture that we're talking about. So the designers work together with engineering as they are designing a new piece of furniture. The engineers have the experience to know what exactly are the motions that are going to be involved into building that piece. So they develop the standard time in parallel with the design of the piece of furniture. So anyways, if we consider that this is the standard time, 0.95 of an hour for product A and 1.85 of an hour for product B, the only thing that we need to know, as we said in this CPOF method, is the historical information. So what is the historical information? So we have here for each work center. So we assume that these two products are manufactured in a facility that has 3 work centers. Maybe one of them is plastic injection, another one is, I don't know, bonding, another one is textiles, fabric, or whatever you want to imagine. So there's 3 different work areas. So historically, the requirements in capacity globally, that involves, in this specific sense, both units, but it could be a lot more of products. So the work center is utilized 60.3% in proportion to the work center 2 and work center 3. So within the 3 work centers, historically, you see we have 100% of utilization here. So it's just spreading how much percent or how much work content you have for these particular parts among each work center. All right. So that being said, we're going to calculate each one of them, right? Because we need to break it down by percentages. So first we calculate the total. And the total comes from getting the requirements for each product, all right? So these are the unit requirements, and this is the direct labor standard hours per unit. So if I just multiply 33 units that I need to do in period 1 times 0.95, I get the total time that I'm gonna need to produce part A in direct labor. And because I'm calculating by work centers overall, and again, remember that we are dealing with the least flexible method. So right now we're talking about aggregate numbers. So the second part that we're gonna use is, well, I need to calculate the direct labor hours as well based on the requirement for product B. So that's 17 times 1.85. And the total of these two tell me that I'm gonna need in period 1 a total of 62.8 direct labor standard hours. All right. Now, based on the historical, how does that distribute among the 3 work centers? Well, I just have to multiply this number right here by the percentages that we have. So 62.8 times 9.3%, that gives me that total of 5.8. So that's 5.8 direct labor hours. This is 19.09 direct labor hours. This is 37.86 direct labor hours. All right. So having this requirement, again, the unit that we're using right now is direct labor hours. Now, you can create a ratio if by hours, taking out breaks and lunchtime and things like that. I don't know, just to say a random number. If a period has a total of 7 hours, then all I gotta say is this divided by the 7 hours that I have within a day. So I need 5.4 people, right? So that's how you calculate your requirement calculation. I need 5.4 people, which could either mean that I have 5 people in the department and then one that borrows 40% of his time between 2 departments, 40% in department work center 100, or we just hire 6 people and have their efficiencies a little bit below of what the requirements are. Now, based on experience, either or decision or either or choice has its own perks. We have been part of projects where, and this one I can remember was one project with Denso, where they wanted to have their material handler, the person that was feeding the lines, to be shared amongst 2 or 3 different lines. So they just, because the requirement was again in a fraction, they just made this person to be supplying 3 different lines. The disadvantage for that is that, well, first, the travel distance that this person accumulated throughout the day was quite substantial, because it's not that he reloaded to fill the 3 stations at the same time, because these 3 stations had different cycles and everything was different. And that was the other thing. If that person wasn't available by the time that the station needed the material, remember, a lot of the processes I have mentioned in Denso work just in time, and some of them are fantastically synchronized. But in this particular area we were looking at, there were a couple of these stations that it didn't work. And that could go more along the lines of the training that the person was receiving and the ease of keeping up with the cycles. But that was just how it presented into that case. But a lot of times management, for a savings initiative, they want to utilize that approach because they don't want to have the extra expense of the 6th person being idle, right? So that's one approach. So were you seeing my Excel spreadsheet?
Yes.
All right, great, fantastic. So I can switch back to the PowerPoint. Now, can you see my PowerPoint?
Enrique?
Yes.
Before you leave that one, the example that you placed below that.
Here.
Yeah, what was that real quick, please? Or what was the
rationale here is that if we say that these periods here are days, and we have a total available time, if we just work one shift of 7 hours, we are measuring this in hours. So if we work for 7 hours within a single day in production, so that means that if I divide this number of standard hours by the total available hours in any given day and any given period, to fulfill this demand in the standard man hours, if you may, I need 5.4 per people.
Thank you.
You're welcome. So I can do this very same exercise for every single day. And this number is only reflecting the work center 100. So I can, oh, well, I don't know why that dragged like that. It should be more proper like this. So you see what is the percentage or the amount of people that you want to have within the department. You have an increase over here over the 13-day or 13-week, whatever you want to decide. I guess for the sake of keeping these 7 could be days. So that's when you decide if you want to go on the constant hiring, constant inventory levels, or if you want to go into the chasing the demand strategy. So yet again, this is for the capacity. So yet if we go back to here, we're pretty much in this part over the long range. So we're dealing with aggregates, right? So the historicals make sense to be used because we're looking at a longer planning stage. Now, all the examples I have here have exactly the same amount of periodicity. So for the concept of explaining how it works, we're going to use the same time intervals, and we're going to just compare how this calculation differs from the other techniques. All right. So that's pretty much what is explained into this slide. It's the same calculations that we just did. All right. So the second technique that we have is the capacity builds. All right. And for this one, we're still in the side of the longer term a little bit. It's rough cut planning. It could be also used in the medium term. And this one still uses the master production schedule information, but it has a breakdown onto that planning that where we incorporate the bill of materials. So we get to know how the requirements that are done for individual finished products based on all the breakdown of the materials that are to be used. All right. So that's why we use it as capacity builds. Indicates basically the standard time to produce 1 unit of an end product. All right. So that means that as we do this breakdown of all these sub-assemblies and sub-requirements, we have to add up each one of these standard times to get the overall, I'm gonna say, you may call it the lead time, right? Or the cycle to get 1 unit out per person or per machine requirement. So once you have that, you connect back to the master production schedule, and then you calculate the requirements for each work center. All right. So this is how the breakdown looks. And for example, in here, we're going to jump back into Excel in a minute. We have the 2 products, A and B. Product A uses parts C and D. Product B uses parts D and E. So you need 2 parts of this to make the assembly into B. And then each one of E needs 2 parts of F. That means that for every B, we're going to require 4 units of F. All right. So then we have the routing and standard time data. So we're going to design the lot sizes, and we're not going to get into the details of these just yet, but in the Excel, you can see a little bit of it. These are predetermined lot sizes based on the, I guess the manufacturing process associated with the product ENF. And these over here go more with kind of the requirement that is associated with the master production schedule. So for the end products, we have all the numbers over here, and then we have the breakdown for the other components, all right? So what that means is that once these two are ready, if we did this in a PERT or CPN diagram, there are certain operations that still need to be held over here. And if we use that prerequisite diagram, then we can establish a timeline, which would be used for the third strategy or the third method technique that we're going to be covering today. So now, from all the operations required, there's only one for component C that is made into two different operations. Every other product is done in a single operation, and they're associated with the corresponding work center. So work center 100 goes with the final assembly. Work center 200 goes with the sub-assembly of components C, D, and F. And work center 300 is going to work only with the second operation for component C. Now, we have to include into the total standard time here, where is from the standard time development, we can incorporate this as part of the, what is it? It used to be called the PDF index, which is personal delay and fatigue factor to calculate standard time. But here we're gonna just include it as a setup for the overall run per unit. So it's prorated for the number of units that you're gonna be having in the run, all right? So if we have the standard setup in hours to be, you need 1 hour to run the lot, 1 hour, 1 hour, 1 hour, 2, 2, 2. So the standard setup hours per unit is just a fraction of these by this. So those are the numbers right here. And then we have a standard runtime. So that's pretty much how long it takes to do the operation in itself for that. And total standard time per operation, or for each one of the blocks into this bill of materials, is going to be just the sum of the standard setup and the standard run. So this is the totals over here. All right. So that's how we come up with the calculations here. And then we incorporate the master production schedule in order to do the calculations based on the totals per department, per work center, for how we're going to obtain the standard times. So let's do one thing, because we already been here 30 minutes. Let's take the 5-minute break. And as we come back, we jump into the Excel in the second tab. So the one that says capacity bill. So that includes the information over here. So I'm going to take it so that you can see each one of the equations into this spreadsheet. All right. Let's pause the video. Take 5 minutes. Thank you. All right. Can you hear me? Let's continue recording. Can you see the Excel spreadsheet?
Yes.
All right, perfect. So remember, this is just an example. So this may help you as a template if any exercises have to be done in the future. You just have to be mindful that as the structure of any assembly or part component changes, this could get more complicated or it could be different. So you just need to consider that part. The important thing is the concept of how you arrange the information and what is the information actually allowing us to do. So this is the same table we just explained. So it has pretty much the breakdown. This one right here, you see a C is a subcomponent of part A. If we need one of it for each one of A as a sub-element, so the lot size is going to be a function of whatever lot size we have for A. Same for D, all right? An exception to that for E and F, to the nature of the process, so the lot size is to cover the minimum requirement based on whatever the departments that process them, right? You said the 200, which covers the minimum requirement given. If we were to break it down from here, E as a part of B, we would be needing, if we need 2 for every one of B, we would need 40 over here, and then we would be needing 80 over here, right? But these two run independently for some constraint associated with either the process or the material. Yet again, so we calculate the standard hour per piece or per unit. So this is the fraction of standard setup, 1 hour divided by the lot size that we're about to run. So that's the formula for this. Standard runtime, that's again the operation, kind of could be either from time studies or could be coming from a predetermined standard time system or anywhere that you find that number. And we just add both of them. So this is the total standard time requirement for each one of the elements in these assemblies. All right. So that being said, then we have to convert this to the standard hours required per department or per work center. So let me just put this work center. Well, I don't know if anybody knows this, but in, I think, Latin America and probably in Europe, well, I guess in Europe as well, WC means the bathroom. So anyways, work center 100. For part A, we just say, well, part A is gonna be at work center 100. We just work here A 100. So that's the total amount that of the standard time that is gonna be used. So that's 0.05. For part B, same case, work center 100, part B 1.3. Slightly different, especially in these 200, since the department 200 is associated with these components, and you know C is part of product A, and then D, E, and F are both of A and then B. So the way to calculate that, we just count for product A. What do we need in product A? We need C and D. So at the departments 200 is 0.6 plus 0.10033. So that's this number right here. For product B, now we have to incorporate the logic of the products, the number of parts that we're going to need for the assembly. So we start by saying that we're going to need this one right here, 0.1, right, of product D, which is this, plus we're going to need 2 parts or 2 times the product E for each one in B. So that's this E times 2, plus for every one of E, we're going to need 2 of F. So we're going to take this time right here times 2 times 2, which makes it times 4. So the total time over here is 0.55. For work center 300, that's pretty straightforward. There's only one thing that is happening at 300, which is operation 2. So that's going to be the 0.2 that comes here. So we bring in the totals. So for product A, this is the standard hour requirement. For product B, this is the standard hour requirement across all departments. Now, if we want to determine the specific capacity requirements, coming back and linking this information with the master production schedule. So we use the same master production schedule that we have here. As I mentioned, that we're going to carry over the same example. As we going through these things, we're dealing into needing more information, reducing the threshold in practice, reducing the threshold of how many days. Is more flexible, but at the same time is more tolling in how to calculate. So the least flexible would be this technique because we're using aggregates and we're using longer term, but it's the easiest to calculate. The most flexible could be this one, right? But it requires more information, and I'm going to tell you exactly why in a minute once we reach there. So as we're looking at this, we don't need historical data anymore. So we're just trying to get from the master production schedule the standard times associated with each work center. So we're going to calculate the total time that we're going to use at work center 100 by just doing the 33 units of requirement times the standard time at work center 100 for part A plus the 17 units times the standard time developed for product B at work center 100. So if we add that up, that's 23.75. Same thing for department 200, requirements times the time, the standard time. Add them up and it gives me the total. And then for department 300, you're gonna use this. And I'll multiply times the requirements and gives me the total. So if you compare here 62.8 based on the historical data, 62.8 based on new information, all right? So how does this make difference? This basically goes through the breakdown of things that need to happen for any subcomponent of this part. So we're no longer dealing with aggregates. We're dealing with the very specific part. So there's a lot of the MRP that has to be associated with it, but the result is fairly similar. If we go through this exercise throughout all the time periods, then we get to see that the totals 939 total hours, 939 total hours. Very, very similar, if not the same. Now you can see one thing that is different here. Based on these 13 periods, the percentages, just by looking at this as a historical data, shift 40, 50, 10. As we initially have said, that was 6 to 30, roughly 10, 9, 3. All right. So you require more information to calculate it this way, but it could add up or help into the precision of how you distribute, especially from a accountability standpoint, because this way you can associate what's going to be the standard cost that you're going to allocate if you're doing ABC costing for your production process. All right. And remember, we're still dealing with capacity requirements. Any questions so far? All right. Let's go to the next technique, which is the resource profile. Still rough cut capacity planning technique that incorporates the production lead time. All right. With this, in production lead time, and in this particular case, we're going to see it's by periods. We're going to get a chart with this time phase. We look at that in the MPS and then in the MRP as well. So we're going to include the time phase projections of capacity for each one of these work centers. It is a bit more sophisticated, but it requires the relatively short time periods to track. Now, again, as I mentioned, we're going from the least flexible to the most flexible, but the level of difficulty in calculating this is a little bit higher. So we get again, the explosion of the bill of materials in this way, but there is one additional part that has been incorporated here. That additional part is that we are doing some kind of, I'm going to say, similar Gantt visualization of what needs to happen when. For the sake of this example, we are dealing with what needs to be ready by period 5, okay? At the end of period 5. So we're going to backtrack of the things that need to occur before. Again, if we use it from a paired standpoint, the requirements or the activities, the nodes that are the prerequisite in order to get a completed part. So if we need certain things that have to be done by period 5, let's assume that we need to have in each prior period subcomponents that are going to feed that particular sequence of parts. So we go 2 periods behind. For every product A that we need, we're going to have to do the previous period, these subcomponents, and then in the 2 periods behind, we're going to need to start the operation with this particular component. Now, we're considering that this is a whole period. Remember that we discussed something about the back scheduling and forward scheduling. So right now we're going to consider that this happens regardless of what time frame it takes, is going to be the period of the whole day, because we're going to deal with be dealing with the overall requirements anyways. So we're going to be looking at everything from perspective of product 5, period 5, sorry. So that means that at work center 200, I need to start for product A in period 3. And this is the time per unit that it takes. And then once I'm done here, then the next period I can move parts and start component C in operation 2. This is a prerequisite of this one. In parallel, I can start working with this. So the way that is presented here somehow represents the back schedule, which is I'm going to start to do the component as late as possible. Remember, we discussed the advantages of doing this, which is reduction in WIP, reduction in resources invested. So the actual capacity is not going to be needed over period 3, but until period 4 for the part that I'm going to have ready by period 5. All right. Similarly, we go with product B. So we have the operation number, the work center that is associated, time per unit, operation, work center, time per unit. All right. So the trick here is that based on that logic, I need to do, as we mentioned, we need to look at it over time. This is time phased. And calculating these from a time phase standpoint, it can be very telling. So it gets more complicated into reaching the calculation. So the Excel is going to explain a little bit more in a higher level of detail what's happening here. But in essence, the calculations are that we need to take into consideration what happens in regards to 1 unit of standard time. So if we want 1 unit of both A and B, what's going to happen in period 3 for each work center. Then what's going to happen in period 4 for each work center, and what's going to happen in period 5 for each work center. And then once we have these breakdown, we just go through the master production schedule and look at the requirements. In the master production schedule for period 5, remember, we're looking at the perspective of period 5 having the completed product. From period 5, we are going to have, according to the master production schedule, 40 units of A and 13 units of B. So all we got to do is I have to multiply these 40 times 0 is 0. 40 times 0.6 is 24. 40 times 0 is 0, right? That's at work center 1, 2, and 3, or 100, 200, 300. I do the same for product B. Nothing happens in work center 300, but 0 times 13 is 0. 0 times 0.25, 13 times 0.25, that's 3.25. And I do subsequently all of that until I get to the totals for the work center for both parts A and B. All right. So let's go to the Excel. Can you guys see my Excel? All right. So this is a representation. This is in darker color is the planning period that we're dealing with. The lighter color is the farther period behind. So if we're gonna look at this, all these calculations that I'm gonna show you are again just for period 5. So that implies that I need to recalculate over all the periods that touch period 5, because I'm looking at end product of period 5 in order to know the total capacity, right? So I know that for period 5 and having end products is going to be 2 periods behind. But then let me just come down. Where did I put it? Right here. Sorry, here. So we did this calculation already, which is basically this number right here, right? 27.25, 7.9, 8.0. So we only look at this part right here. But in order to calculate the total capacity, there are 2 other time intervals based on the breakdown. If I'm gonna phase everything in 3 time intervals, there are 2 other time intervals that I'm gonna touch period 5, which is the production that has to have a finished product by period 6, and the production that needs to have a finished product by period 7. And remember, because we start 2 lags behind, so this runs from 3 to 5, this runs from 4 to 6, this runs from 5 to 7. Okay, all of these 3 include period 5. So then we do exactly the same thing. So this part I have right here is this top part in the PowerPoint. This yellow part right here, the yellow thing, is this bottom part of the PowerPoint. So if you click here, you'll be able to see all the calculations, where it's coming from, and these are the totals of each one of these. So I know that for period 5, I'm gonna need, from this perspective, in this time interval, 18.9 standard hours at the work center 100, but 0 at work centers 200 and 300, right? But yet, let's move one period forward. So instead of going periods 3, 4, and 5, again, that's the sequence that we have here, periods 3, 4, and 5. This is what needs to happen. Now, imagine we're moving one stage ahead, forward. So now this is 4, 5, and 6. The same things need to happen, these things and these things, but now it's 4, 5, and 6. So that's the 4, 5, and 6 right here. And if I go to 4, 5, and 6, I am going to backtrack from the finished product being in period 6. So period 5 told me that I needed 40 of the product A, 13 of product B, right? So in period 6, which is the finished product, I'm still gonna need the same according to the master production schedule. So the numbers are exactly identical because the requirement is the same as period 5. So I'm still gonna be 18.9 and all this same distribution of numbers. But what happens if we jump to period 5 to 7, to range from 5 to 7? The requirement in the master production schedule changes. It's requiring 10 less of product A and is requiring 12 more for product B. So now I have to calculate everything, backtracking the 2 periods in the lag for these new requirements. So I'm using my standard times over here, and I'm going to start producing 30 units for product 7, right? Because we need to start with the subcomponent, which one was it? Subcomponent C in operation 1, and that's going to be this multiplication. So there's nothing that will occur in department 100. So the subcomponent, it actually occurs in department 200. So that's how we get this for product A, which is that 0.6 times 30. We get that subcomponent, and then 0 for the department 300. We do exactly the same calculation all over. Pretty much you can drag this formula and it will work. Well, you will need to change this, the value for this one, because the requirement is for product B. And then I get the totals, and I see that my totals are slightly different. So now instead of having this, my total increased to 34 units in department 100 for period 7, all right? But remember, we are looking at the perspective of period 5. So I'm going to shift the color, change the color here, because we already made the calculations for anything that touches period 5. In here, period 5 is dealing with the finished product. In here, period 5 is dealing not with the finished product, but with the components, the components that are going to be assembled here. And over here, in this third one, period 5 is going to be doing the very first step that is required to have a finished product in period 7. by doing all of this, I just took the totals here, and I put them, I chart here from periods 3 to 7. So this is what's going to happen in what we explained first, and then with the lag, this is what's going to happen in these periods, and then the last one, this is going to happen within these periods. But yet again, reds over here this is my point of interest. So that way I can calculate the requirements that I need for the period number 5. The period number 5 is not just going to be, because that's the impression that we get from the Excel, that it's going to be only this. No, it's everything that touches period 5 into the production plan. So once I add all of them up, Department 100 at period 5 is going to require a total of roughly 19 standard hours. Department 200 is going to require a total of 32 standard hours. And Department 3 is going to require a total of 8 standard hours for a final number of 5906. Let's compare with the other methods. Period 5, 62. Period 5, 62. So we go into having a requirement that is a little bit lesser, but because we incorporated more information into how we calculate the capacity here. That's what the resource profile means. So you see, all of this mess was just to calculate this. So I'm giving you the numbers because we already have some of it. As we do each one of these steps, we had information here for period 3. We still need to have 2 more boxes similar to this to get all the information for period 3. We got 2 of the 3 boxes for period 4, so I just need to do 1 more of period 4, and I would complete the information. And same for 6 and 7. I have 2 boxes out of the 3 for period 6, and I only have 1 of the 3 boxes for period 7. If you repeat this calculation 3 times for each one of these, you would be able to fulfill the entire table of the capacity requirements. So as an exercise, just to make sure that you grasp, because this is a little convoluted, you already have 2 of the 3 boxes for period 6, and you have the responses here if you want to validate the prior periods. But please, let's take about 10-15 minutes, so it's time for another break almost. Instead of having the break, let's take the 15 minutes so that you can calculate the requirements for period 6 and 7, please. We can pause the recording while this is being calculated. All right. Do we have some answers already? Does anybody want to share the response?
I think we're all scared to.
Go ahead, give it a try.
I kind of missed it all there on how that goes back. So but I got about a portion of the way into it and lost it on what the calculation should have been. So I'm tied up on it.
All right. Anybody else that tried to complete it? Or let me rephrase this. Are there any specific questions where I need to go through again into the process?
For me, I'm going to have to go back and watch the whole thing or that piece of that segment of it to catch it, unless you went back through it again.
Oh, I can do that very, very quickly, but I just want to make sure that if there is anyone else that have made the calculation. Anybody, guys? Nobody?
As you said, it's very intricate and it can get very confusing. So I think having the ability to print it down and look at it and make notes and kind of tie things back, will help make sure we're picking up the right cells with the calculation.
All right.
So should it be that difficult, Enrique? Or should it flow a little easier?
I guess that's a good question. Let me try to calculate the period 6. So let's see if by doing that, we can get the response and maybe clarification on how to do this. All right, so I wrote down just the numbers of the responses for 6 and 7 down here. I'm going to blank this out. So we calculated period 5, right? I'm going to calculate, for the sake of speed, I'm just going to calculate for period 6, all right? Given that we already have these twice now. Okay, so I guess I'm trying to see how can I make it clear. If we look at this as a precedence diagram, in order to get a finished product, and I hope this is the easy part. In order to get a finished product, I need to start in, we can call this period 1, period 2, and period 3. So it's gonna take me 3 periods if I start from scratch to get 1 unit out of this product, right? So it's gonna take me through 3 different periods of this master production schedule to get 1 unit out from 0, from scratch, at the end of that 3rd period, okay? So arbitrarily, in this example, we started with period 5. We want to have a unit out at period 5. So we start producing at period 3, and then with the component, and then we go to the next operation for the component. These are part A, and this is for part B. So this happens in a sequence of 3 steps or 3 periods regardless when you start, right? Whenever you start, it's gonna take you 3 more periods to have it done. But as you're doing that, you're using resources in each one of the work centers. So these are the work centers that are being used. Work center 200, work center 300, and work center 100. Work center 200, 300, 200, 100, all right? What we want to calculate here is what are the resources that we're gonna need, global number of resources that I'm gonna need in any given period, all right? So if I'm saying that it takes me 3 periods, and if I want to arbitrarily decide to start looking at period 5, I made all the calculations here for which period 5 has something to do. Let's call it period 5 to be Friday, today, right? So on Friday, I'm going to start a batch for whatever needs to be ready by Tuesday. If we just call that it's Monday through Friday. But also I'm gonna be in the middle of working to whatever it needs to be ready by Monday. And I'm going to be finishing whatever needs to be ready today, right? So I'm gonna be doing these 3 things because everything goes to three periods. So now let's take that logic, the calculations associated with that are here, to calculate what has to happen on period 6, right? So over period 6, and I'm just going to insert this over here. And I'm going to copy this and paste it here, right? I'll make the adjustments right now in a minute. Now, because we are changing the example, I'm going to change the color here to orange so that we keep track of it. Now, 6, 7, 8. So that means that if I start looking at the perspective of period 6, I have to work with the requirements. Sorry, 1 second here. The video part is getting across. I'm gonna put this black, black, and black. All right. So now what I want to do is how many resources I'm going to need for period 6. All right. From this logic of 3 periods that are required to produce a unit, I'm going to be, if I'm looking at month 6 as Monday, on Monday, 3 things are going to be happening. On Monday, I'm going to start the production that needs to be ready by Wednesday, right? Which is this. This is Wednesday, this is Monday. So I need to start working on whatever has to be ready by Wednesday. I'm going to be in the middle of whatever needs to be ready by Tuesday. And on Monday, I'm gonna be finishing whatever started yesterday, right? Does this logic make sense?
Yes.
All right. So that being said, I already made these calculations, right? So I need to know what are the things that have to happen for the order that I need to finish on Wednesday. So that means that, 1 second. So if I'm here, whatever needs to be finished by period 6, that started yesterday is this. If I'm here, this needs to be be finished by period 7, right? So that means that I'm going to make the requirements of whatever needs to be finished by period 8, right? And that goes with each standard time that I have associated with the requirements for the 3 periods. Let's remove these titles of 3, 4, 5. Let's just call period n plus 1 and period n plus 2. If we're dealing with the starting, I guess it's more appropriate if I do period n when I want it to be finished, and then n minus 1 and n minus 2. So n equals period when the product must be finished. All right. So I just associated that with connected the requirement that the period n is going to be 8 when the product must be finished. So the requirement is 30 units, and at the standard time 2 periods before is going to be that. So I just drag and drop the formula. So I make sure that it's doing the right thing. Yeah, same requirement and the standard time. And then I just drag and drop this formula. And we have all the requirements. Now I have to do the same thing for product B. So let's go to 100 here. And then the I-27 period n is going to be 8. So I'm going to drag that over there. So I'm going to just move all of this. Verification. Yeah, we have here, and it's still over period 8. All right. And then
can you pause right there for a moment and show the formula?
This one?
Any of them. I just want to make sure that I've.
Yeah, I'm with her. Go back to that first one on where you get for period 8 to 1.5. For whatever reason, I get 0, so I'm not sure what I put in there versus you. So
you have to have.
Oh, it's the n. I'm going back to the n minus 2. I'm sorry.
Right. All right. So basically, I just need to make sure, calculate 1 in each, and then drag and the formula across this. So this is already done because we just copy pasted from here. I'm going to shrink this. So these are the totals. So now, given those requirements, let's build a very similar table to this one that we have right here. Actually, I can just incorporate period 8 over here and say that I'm going to insert that. I'm going to copy, and this is from period 6 to 8. So this matrix can be completed for all the ranges of 3-day or 3 interval periods. All right. So because I already had all of this, the only one that I need to complete is this one, which is the one that I calculated over here. So all I did was to create the equals there. So that's going to mean that I just do the very same thing. This equal this, and just drag. All right. And now the verification here is that I need to have, let me just highlight probably in this way. 1 box there. 1 box there. 1 box there. For every time, because the matrix is 3 interval periods, we have to have 3 ranges. So every time that I want to calculate the requirement for one specific period, I have to make sure that I have completed the exercise for these 3 ranges. So for interval 6, for period 6, I already have all the data that I need. So all I have to do is, well, I need to modify these formulas, but all I have to do is to get the totals over here. And I drag and drop. And then this is the sum of the 3. And those are my requirements. So I calculated the requirements because we have to, in the capacity that we need to have a plan for in period 6 involves anything that is going to touch that period, whether we are starting in the middle or finishing up the product, right? So this case is very easy to exemplify from that perspective, that we only have 3 options: when we are starting, when we're in the middle, and when we're finishing. I need to be sure that I can do those 3 things in a single time interval. That's all I'm doing. So over here, I'm going to be starting, I'm going to be finishing what started in time interval 4. I'm in the middle into whatever is started on time interval 5. And I'm going to start whatever needs to be ready by period 8 on this particular day. So I need to be able to have the capacity for the 3 things. So I just add the requirements on those capacity according to the master production schedule. And that tells me that this is the number. So if I go back here and just to drag the values, I do dot is equal to that. And I drag it down. That tells me that I need 18.9 standard hours for department or work center 100, 34.76 for the 200, and 6 for the 300. If we compare this with the result that I had down, just because of the decimals, there's a slim difference over here, but the other 2 are exactly the same. So what do we need to do if I wanted to calculate for period 7? Same thing. I just insert more tables here. I copy this, paste it here, and I start period 7, 8, 9, right? So again, I have the information for finishing the product, for being in the middle of the product, and for starting the product. So I just need to recalculate this part. The product is going to be ready by period 9. So I have to go to the requirements of period 9. And the standard time is going to be the same, and -2. Then I drag and drop. There you go. Let's go to the requirement of period 9. I just move this one forward. And then over here, the cell that should correspond to is this one. So I have department work center 100 there. I drag, and I have my new totals. So in order to calculate that, I can incorporate period 9 over here. I can just insert cells here, shift cells down, copy these from 7 to 9. This is exactly the same, work centers. And I just need to bring in, it's defaced here. So this is going to be equal to this. Drag, drop, drag, drop. Right? And now I have the three intervals for period 7. So all I gotta do is copy paste. I move this one down, drag this 3, and those are my requirements. So if I go back to the table of capacity requirements, I just drag this to the right, 34, 34.78, 76, and 6. Those are the results. All right. So you just need to repeat the algorithm for every another period that you want to calculate. And you go on and on and on and on and on and on until you complete the time interval that you want to have the scope for the requirements, the capacity requirements. Is it clearer now?
Yes.
Fantastic. All right. So let's go back to the PowerPoint. So the last technique is the capacity requirement plan. And this is pretty much different from the 3 other methods, that this doesn't connect directly to the master production schedule. It goes directly to the material requirements plan. So by doing so, we're going to start accounting for inventories. We're going to start accounting for WIP. We're going to start accounting for scheduled parts to arrive. But just like you saw in the previous example, we need to do a lot more calculations into this one. So I'm going to just show you the example that goes for one work center. So this is just one work center over a specific time frame. So we're going to be looking at the master production schedule. If I go back to the PowerPoint, it's the same information here. So this is the MRP data that we're going to include. And this information then is transformed by the standard hours by the calculation, by the information that we have in the initial the initial table on the CPOF. So basically, we're going to just deal with product A right now and work center 300. So this goes into having the 13 periods. The requirements are the same for product A. But now we have that the policy we decided for the MRP is that the lot size is going to be about 40, and that the lead time is going to require 2 periods. All right. So that's the same that is provided here in this part. And we're working only with component C, which is mentioned here. Component C of product A for work center 300. Okay. So the gross requirement of component C, if we go back here, is for every part of A, we just need one part of C, right? So that's exactly what we're going to be requiring. So we could do the MPS times the requirement, and it counts like this. But this could be information that is retrieved directly from the MRP. So this is 33 of that component C that we're going to need. All right. And then because we have from the previous period that we're not accounting here, we had some inventory. So we had certain availability. Now, 2 key things are going to be here. you remember that we covered about scheduled receipts. So we have a scheduled receipt into this time interval that could be accounted for the very beginning of the process. This was processed somewhere. It was at some place. It might have been of another vendor. We are not processing it. We don't know. But we have to start, and then we have the lag of the requirements because the lead time is the subsequent period. So if we need 33 and I have 37, my projected availability, it's 4. So my planned order release is 40, right? This 40 is going to become available until the next period because I have 2 lags of lead time. And all I need to know is, first, what is the setup time? So that goes, if we go to capacitive bill F14, so that's F14 is right here, component C. And we know that we have this 1 unit. Sorry, let me go back here. Of standard setup time. So it requires 1 hour. Plus the 40 hours that we need for the initial run. That's a plan order release. Times H14, which is this one right here. Component C at step 2, remember we're dealing with work center 300. So we require 40 hours for the run. We multiply that, the standard run time. So we add this plus this. We get that we need a total of 8 hours to produce this particular thing. Then, just like we were doing in the MRP, these are the requirements that are going to be associated, and we just start projecting availability. So we have these 4 units on hand, plus the scheduled receipt, minus the requirement that is going to be associated with the MRP. That leaves us with a total of 11 units. If I go to the next step, so I plan an order of 40. I go to the next one. And because of the 2 lags into the period of the order release, so whenever I plan an order release here, it's going to come back 2 periods later, right? So I start with this 11, plus if I had any scheduled arrivals, minus the requirement, plus the planned order release that are going to have available from 2 periods behind. That's 18 units. And I go like that all over. And the standard hours are going to be these particular required hours, right? As we move forward. So there's a lag of a period because we're going to be producing this in the next period, which is going to be ready by the next period, right? So that's how the logic works. So the total number of hours that we require just for Work Center 300 for component C over the 13 periods is going to be 88 hours. All right.
So could you show us that scheduled line item 10 there? What is that?
Line item
scheduled received. Where your 40 is, you went to F10 to create the next one?
Right, this one?
Yes. So you go to figure out the next, hang on, catch up to it. If you go to figure out item 3 or number 3 or column 3, F, sorry.
Yeah.
Yes, there. That E12 plus F10. Will you explain that again, please?
Yep. So that's the material that I had available. So that's the carried inventory. That's
yes.
Here projected availability.
plus I don't have any scheduled receipts, so that's 0.
Okay.
Plus, I'm gonna skip this, meaning pardon for the order, but plus whatever planned order I had in the 2 periods behind, because the lead time is 2. So I'm gonna have this material available here, right?
Yes.
The lead time is right here, minus the requirement that I planned for doing today.
Gotcha.
So that leaves us with a total of 18 units in inventory.
Okay, got it. Thank you.
All right, and I use that again as the inventory that I carried, and I just go through the same formula over and over and over again.
Right. Yeah. Thank you.
You're welcome. All right, so that's pretty much to repeat this process for each work center to complete the plan. So you see, as we went from the first one to this one, the complexity is much higher. So at this point, I guess the plan for next session was to shift into a new topic. But I believe that given that we are right in the middle of this, what I'm gonna do is make an adjustment again. So for next session, we're gonna continue right here for the capacity and materials. But I just hope that with today's information and going through the 2 simulations that you have already done, and including all the topics that we have covered, that you're more prepared for the simulation number 3. Why? Because in simulation number 3, the time period that we're going to be working with is going to be twice as long, roughly, so that you have the same time frame to work with the report, but you're going to have 2 weeks to see much more of the effects of the decisions that you make. And there you can start incorporating all these type of planning tools to decide how you're going to be doing this. Now, my recommendation to you as you go through these items is that think of where exactly are you dwelling with when you start the simulation, when you're in the middle of the simulation, and when you're at the end of the simulation. And how those decisions affect, or what's the information that you're using to make the decisions that you have made according to controlling production. Now, for some of you, it might be too intuitive already. For some others, for time limits or whatever it is, it might not be as transparent. But if you apply the principles within this schedule of the manufacturing planning and control, I hope that you would get much better result than if you just go by the simulation. And at this point, we have gone through a couple of simulations where you have gained a little bit of experience on how it works. Now, the conditions on each one of the simulations have shifted. So the third simulation is going to be the same factory, the same products, but the conditions may change, right? Well, not may, will. Conditions will change. So you have to pay attention to those details, all right? I think somebody asked in the previous simulation that if whatever result you had from simulation 1 carried over to simulation 2, that answer is no. So the same thing is going to happen to simulation 3, is starting over. So whatever result you get from this simulation number 2 is going to be wiped off and just start again. And it's a different, technically it's a different game that you're going to be playing. So we're going to go through the midterm next session as well. And as we make the adjustments, we're going to be giving out the schedule of the remaining activities for the next session. All right. So remember, you have a report due on Monday. And I hope that you guys have a good weekend.
Thank you, Dr. Enrique.
Thanks, Dr.
Enrique, could you stay on for just a second? I have a couple of questions about the report and
Sure, sure. Yeah, I can stay.
Have you seen the results of the last simulation? Are you able to see that yet, or do you just see the reports we turned in?
I am able to see the simulation.
Okay. Our group made an error at the very end there. I'm team 2.
1 second.
You're fine.
Let me just open it so that I know specifically what you're talking about. Okay. All right. Okay, team number 2.
Yes.
Okay.
So at the end, for those last, what was it, 50 days, the simulation was going to run without us being able to control anything.
Right.
We tried to forecast based on the previous demand exactly how many units we would need so we didn't end up with excess inventory.
Uh-huh.
And it looks like we got it right up to the end because at the end of the simulation, our inventory hit 0 there.
Yep.
And we set it not to reorder, but we got messed up by the simulation where you can't change 2 things at once in that in the ordering part of it. So we set it to order 0 parts at 0 inventory, thinking that would just default make it not order anything. But it looks like at the end there, it made 1 more order for us because we changed 2 things at once.
Uh-huh.
And we were so close to getting first. I was just curious if you would let us out of that midterm. We think we got, I mean, we're right there. We're like 0.2% away from the first place team. What if we just called it a tie?
Remember that you still need to turn in the report.
It's gonna be a fantastic report. We forecasted it. Look at that. That's at 0 inventory by the end. The calculation was perfect.
Yeah. Let's see. Turn it in and then we'll decide.
All right. Thank you, Enrique.
No problem.
I appreciate it.
All right. Bye-bye, Dr. Enrique. Bye, guys.
See you. Thank you.